Welcome to the channel Sleepy Documentary. I'm glad you're here tonight. You don't need to bring anything with you. Not focus, not energy, not even curiosity. You can simply arrive as you are. If you're already feeling sleepy, that's welcome. If you're wide awake, that's welcome too. You might notice your breathing slowing on its own, or the gentle weight of your body wherever it's resting. There's nothing to do about that. Tonight, we're exploring the most relaxing facts about our solar system. Our solar system is a wide, quiet place. It holds slow-moving planets and drifting moons, pale rings made of ice and dust, distant storms that have turned for centuries, and shadows that stretch for millions of kilometers. There are rocky worlds warmed by sunlight, and frozen ones, where sunlight is only a faint glow. There are asteroids tumbling softly in the dark, comets tracing long, patient arcs, and empty spaces so vast they almost feel like silence. Everything we'll talk about is real, observed, measured, gently understood by generations of astronomers looking up and outward. And yet you don't need to hold any of it. You can let the details pass through you like starlight through open air. Some parts may interest you, some may blur, some may drift away entirely. If you find yourself enjoying this kind of quiet science companionship, you're always welcome to return another night. Far beyond the warmth of Earth, beyond even the quiet red deserts of Mars, there is a planet that turns so slowly it almost seems to hesitate. Venus rotates once every 243 Earth days. That means a single Venusian day, one full spin, lasts longer than its year, which is only about 225 Earth days. The planet completes an orbit around the Sun faster than it completes a rotation on its axis. Astronomers confirmed this through careful radar measurements, watching subtle surface features shift over time. It is a real, measurable slowness. If you could stand on Venus, which you cannot, because the surface is intensely hot and the air is crushingly thick, the Sun would rise in the west and set in the east. Venus rotates in the opposite direction from most of the other planets. This backward spin is called retrograde rotation. It is not dramatic out there. It is simply how that world turns. You don't need to picture it perfectly. It's enough to imagine a planet taking its time, a sunrise that would not rush, a horizon that would change almost too slowly to notice. And somewhere in that vast sky, clouds made of sulfuric acid drifting in layers, wrapping the planet in bright reflection. Venus reminds us that time is not the same everywhere. A day does not always mean what we think it means. Sometimes a world turns gently, almost reluctantly, in a rhythm all its own. And if your thoughts are moving more slowly now, that's all right. Nothing in this solar system is in a hurry. Not even the planets. Farther out, past Mars and the scattered rocks of the asteroid belt, lies Jupiter, enormous and steady. Jupiter is so massive that it contains more than twice the mass of all the other planets combined. Its gravity shapes the architecture of the solar system. Asteroids curve under its influence. Comets alter their paths when they pass nearby. Even the Sun shifts slightly in response to Jupiter's pull, as both bodies orbit a shared center of mass. Jupiter rotates quickly, once every 10 hours, and that rapid spin stretches its clouds into long, colored bands. These bands are made of ammonia crystals and other compounds, rising and falling in vast atmospheric currents. Embedded within them is the Great Red Spot, a storm that has been observed continuously for more than 300 years. It is large enough to swallow Earth whole. And yet, despite its size and its storms, Jupiter sits far away in the cold dark, orbiting the Sun every 12 Earth years. Its presence is not loud. It does not roar in space. It simply turns and turns and turns. You may find it comforting to know that Jupiter also acts as a kind of gravitational shield. Many comets and asteroids that might otherwise travel inward are captured or deflected by its immense pull. In that sense, this distant giant has quietly influenced the stability of the inner planets for billions of years. If this detail fades as you listen, that's okay. The important thing, if there is one, is that somewhere out there, a vast striped world is spinning steadily, holding its storms, shaping the paths of smaller things, and keeping its long, patient orbit in the dark. Saturn drifts even farther from the Sun, wrapped in its wide rings. The rings are not solid. They are made of countless pieces of ice and rock, some as small as grains of sand, others as large as mountains. Each piece follows its own orbit around the planet, guided by gravity and momentum. Together they form broad, luminous bands that reflect sunlight with a soft brightness. The rings are astonishingly thin. In many places, they are only about 10 meters thick, thinner than a city building is tall. Yet they stretch across hundreds of thousands of kilometers. From a distance, they appear delicate, almost fragile. Up close, they are busy with motion, every fragment circling in precise alignment. Moons move within and near the rings, their gravity carving gaps and shaping edges. These moons are sometimes called shepherd moons. Their presence keeps the rings structured, preventing them from dispersing completely. If you imagine standing on one of Saturn's moons and looking up, you would see the rings arching across the sky like a luminous bridge. They would not move quickly. Their shift would be subtle, almost imperceptible from moment to moment. You don't need to visualize every particle. You can simply hold the idea of a planet wearing a halo of ice, each piece circling calmly in silence. The solar system contains structures both grand and delicate at once. Massive planets and thin rings, slow orbits and steady rotations. And if your awareness is softening now, you are moving in rhythm with these distant cycles. Nothing about them requires your effort. They have been circling for millions of years without asking to be understood. Beyond Saturn, beyond Uranus with its sideways tilt, lies Neptune, a deep blue world shaped by wind. Neptune is farther from the Sun than any other major planet. Sunlight there is faint, about 900 times weaker than on Earth. And yet Neptune hosts the fastest winds in the solar system, reaching speeds of over 2,000 kilometers per hour. These winds move methane-rich clouds across the planet's atmosphere, giving Neptune its blue color. Storm systems form and fade over years. Dark spots appear, drift, and disappear. The energy driving these winds does not come mainly from the Sun. Neptune radiates more heat than it receives, releasing internal warmth left over from its formation. It is a quiet reminder that not all motion depends on nearby light. Some energy is stored deep within, released slowly over time. Neptune takes 165 Earth years to complete one orbit around the Sun. Since its discovery in 1846, it has completed only one full orbit. A single Neptunian year is longer than any human lifetime. Generations pass while that distant planet traces its path. You may notice your thoughts lengthening as you consider that scale. Or perhaps the numbers simply pass by. That's all right. The point is not to calculate. It's to sit beside the idea of a blue world, circling slowly in cold darkness, winds flowing across its surface without sound. Even at the edge of the planetary system, motion continues. Rotation, orbit, internal warmth, steady persistence. And then, beyond Neptune, there are smaller worlds. Pluto, once called the ninth planet, now known as a dwarf planet, follows an elliptical orbit that sometimes brings it closer to the Sun than Neptune, and sometimes far beyond. Pluto's surface holds nitrogen ice plains and water ice mountains. It has a large moon, Charon, so close in size that the two bodies orbit a shared center in space between them. They are gravitational partners. Pluto's year lasts 248 Earth years. Its sunlight is pale and distant. Yet even there, seasonal changes occur. Thin atmospheres form and freeze as it moves along its orbit. Ice shifts. Shadows lengthen and shrink. The solar system does not end abruptly. It thins gradually. Beyond Pluto lies the Kuiper Belt, a region filled with icy bodies orbiting in quiet loops. Beyond that, the Oort cloud may extend nearly a light year from the Sun, a vast spherical shell of frozen remnants from the system's formation. All of it remains bound by gravity. All of it continues in motion. If some of these names fade, Kuiper, Oort, Charon, that's completely fine. What remains is the sense of distance, of structure, of a family of worlds moving together through space, not chaotically, not urgently, just continuously. And as you rest here, listening or drifting, you are also part of that motion. Earth is turning beneath you. It is orbiting the Sun. The Sun itself moves around the center of the Milky Way. None of this requires your awareness. It continues whether you follow it or not. You can let the solar system hold its own rhythms tonight. You don't need to keep track. You can simply rest while the planets turn. Earth's moon is moving away from us. Not quickly, not dramatically, but steadily. Measurements taken with laser reflectors left on the lunar surface during the Apollo missions show that the moon drifts about 3.8 centimeters farther from Earth each year. That's roughly the rate at which fingernails grow. Astronomers know this because they bounce pulses of light off mirrors placed on the moon and time how long the reflections take to return. The distance changes, slowly, predictably. This outward drift happens because of tidal interactions. Earth's oceans respond to the moon's gravity, forming tidal bulges. As Earth rotates, those bulges are carried slightly ahead of the moon's position. The gravitational pull between the bulges and the moon transfers a small amount of energy outward, nudging the moon into a slightly higher orbit. At the same time, Earth's rotation slows by a tiny fraction. Days lengthen gradually over millions of years. Long ago, when the moon first formed, it was much closer. Tides were stronger. The moon would have appeared larger in the sky. Now it continues its quiet retreat. You don't need to calculate the distance. You don't need to imagine millions of years precisely. It's enough to know that the night sky is gently rearranging itself, centimeter by centimeter, year by year. A patient widening, a gradual loosening. And if something in your own life feels like it's slowly shifting, almost too slowly to notice, that rhythm exists in nature too. Not abrupt, not urgent, just steady change carried forward by gravity and time. Mars holds the largest volcano in the solar system. Olympus Mons rises about 22 kilometers above the Martian surface. That's nearly 3 times the height of Mount Everest. It spans roughly 600 kilometers across, with slopes so gradual that if you stood near its base, you might not realize you were on a volcano at all. Mars lacks the plate tectonics that constantly reshape Earth's surface. On our planet, tectonic plates move over hotspots, spreading volcanic activity across chains of islands and mountains. On Mars, the crust remained largely stationary over a plume of rising magma. For millions of years, lava built up in one place, layer upon layer, forming a vast shield volcano. The atmosphere on Mars is thin, and the gravity is weaker than Earth's. These conditions allowed Olympus Mons to grow taller and wider than any volcano here. It is not erupting now. It rests. If you imagine standing far away on the Martian plain, you might see its slope merging with the horizon. The sky would be pale, tinted with fine dust. The volcano would rise slowly, almost imperceptibly into the thin air. There is something calming about a mountain formed not by sudden upheaval, but by steady accumulation. Layer upon layer, heat rising quietly from below. Time building structure without hurry. You don't need to hold the dimensions in your mind. You can simply carry the image of a broad, sleeping volcano on a red world, waiting in silence beneath a distant sun. Uranus rotates on its side. Its axis is tilted about 98 degrees relative to its orbit. That means it effectively rolls around the sun, with its poles taking turns pointing almost directly toward the light. Astronomers believe this extreme tilt may have resulted from a collision long ago, perhaps with an Earth-sized object. The impact would have altered the planet's orientation permanently. Because of this tilt, Uranus experiences unusual seasons. Each pole spends about 42 Earth years in continuous sunlight, followed by 42 years of darkness. Decades-long days, decades-long nights. Its atmosphere appears smooth and pale blue from a distance, composed largely of hydrogen, helium, and methane. Beneath the clouds, pressures increase. Deeper still, there may be layers of water, ammonia, and methane in exotic states, sometimes described as icy, not because they are cold, like familiar ice, but because of their chemical composition. The planet rotates once every 17 hours, even as it slowly circles the sun over 84 Earth years. If you picture it, you might imagine a sphere tipped gently onto its side, rolling through space with its faint rings encircling it vertically. Sunlight falling on one pole for decades, the other waiting patiently in shadow. It does not correct itself. It does not hurry to stand upright. It simply continues, stable in its tilted orientation. If your own rhythm feels slightly off from others, slightly different, slightly angled, that too exists among the planets. Not everything stands straight. Some worlds roll quietly through the dark, perfectly balanced in their uniqueness. In the asteroid belt between Mars and Jupiter, millions of rocky bodies orbit the Sun. Some are as small as pebbles. Others, like Ceres, are nearly 1,000 kilometers wide and classified as dwarf planets. Despite the way they are often depicted in films, the asteroid belt is not crowded with tumbling rocks constantly colliding. The objects are spread across a vast region of space. The average distance between sizable asteroids can be hundreds of thousands of kilometers. Space, even there, remains mostly empty. These remnants are leftovers from the early solar system, material that never coalesced into a full planet because of Jupiter's gravitational influence. Jupiter's pull stirred the region, preventing stable accumulation. Some asteroids are rich in metals. Others are composed of carbon-rich compounds. Some contain water ice locked within their structures. Occasionally, fragments are nudged inward, becoming near-Earth asteroids or meteorites that fall through our atmosphere as brief streaks of light. But most of them simply continue their loops. Quiet, predictable, bound by gravity. You may imagine one of these bodies circling the sun, rotating slowly, sunlight warming one side, darkness covering the other. No sound, no friction of air, just motion along an invisible path. The asteroid belt is not chaotic. It is structured by mathematics and time. If your thoughts are scattered tonight, that's all right. Even scattered objects can follow stable orbits. Even widely spaced fragments can share a common center. Gravity is patient. It does not demand closeness. It only maintains relationship across distance. And in that sense, the solar system is not crowded at all. It is spacious. Each object given room to move. The sun itself, at the center of all this motion, converts about 600 million tons of hydrogen into helium every second through nuclear fusion. In that process, a small fraction of mass becomes energy, released as light and heat. This energy takes thousands of years to move from the sun's core to its surface, passing through dense layers of plasma. Once it escapes as sunlight, it travels across space in just over 8 minutes to reach Earth. 8 minutes of travel after thousands of years of slow internal migration. The sun has been shining for about 4.6 billion years. It is roughly halfway through its stable life cycle. It will continue this steady fusion for billions more. It does not flare constantly. It does not change unpredictably on human timescales. It glows with remarkable consistency. You don't need to picture the nuclear reactions precisely. You can simply hold the idea of steady radiance, a star maintaining equilibrium through immense internal balance. If you feel warmth on your skin during the day, that warmth began as interactions between atomic nuclei deep within a sphere of plasma long before any human moment. The light that reaches you tonight, perhaps reflected from the moon, left the sun minutes ago. But its deeper story began far earlier. Energy moving outward, slowly at first, then swiftly across empty space. And here you are, resting on a planet sustained by that continuous glow. If some part of this explanation fades before it finishes, that's perfectly fine. The sun will continue shining, whether or not you follow the details. Everything in the solar system moves in quiet coordination. Moons drift, volcanoes rest, planets tilt, asteroids circle. Light travels, and you don't need to keep track of any of it. It is enough that it is happening. Mercury is the closest planet to the sun, and yet it is not the hottest. That distinction belongs to Venus, wrapped in its thick atmosphere. Mercury, by contrast, has almost no atmosphere at all. It cannot hold heat efficiently, so its temperatures swing widely. In sunlight, the surface can reach about 430 degrees Celsius. In darkness, it can fall to minus 180. Because Mercury rotates slowly, once every 59 Earth days, and orbits the sun in just 88 days, its pattern of sunrise and sunset is unusual. If you could stand on its surface, you would see the sun rise, pause, reverse slightly in the sky, and then continue its path. This happens because Mercury's orbital speed and rotational speed interact in a precise ratio called a 3:2 spin-orbit resonance. For every 2 orbits around the Sun, Mercury rotates 3 times on its axis. Astronomers calculated this through radar observations in the 1960s, measuring subtle echoes that revealed its true rotation period. Mercury's surface is heavily cratered, similar to our Moon. It holds long cliffs called scarps, formed as the planet slowly cooled and contracted over billions of years. Even now, it may still be shrinking slightly, its iron core radiating residual heat into space. You don't need to follow the numbers. You can simply imagine a small, rocky world turning slowly near a bright star. Light blazing on one side, cold shadow on the other. A long sunrise that takes its time. Extreme contrasts can exist peacefully side by side. Heat and cold, motion and pause, brightness and darkness. On Mercury, they alternate without conflict, part of the same steady rhythm. And if your own thoughts feel warm one moment and distant the next, that too can simply be part of a natural cycle. Saturn's moon Titan holds lakes, not of water, but of liquid methane and ethane. Jason is the only moon in the solar system with a thick atmosphere. That atmosphere is rich in nitrogen, similar in some ways to Earth's, though far colder. Surface temperatures hover around -179 degrees Celsius. At that temperature, methane behaves the way water does here. It forms clouds. It falls as rain. It gathers into rivers and pools. The Cassini spacecraft and the Huygens probe revealed shorelines, river channels, and vast seas near Titan's poles. Some of these seas are hundreds of kilometers wide. Waves may ripple across their surfaces under gentle winds. Beneath Titan's icy crust, scientists suspect there may be a subsurface ocean of liquid water mixed with ammonia. The interior may be layered, rock at the center, surrounded by water, then ice, then atmosphere. Titan orbits Saturn every 16 days, locked in synchronous rotation so that the same face always points toward its planet. Saturn hangs large in Titan's sky, though often obscured by orange haze. You might picture standing at the edge of a methane sea, beneath a dim, copper-colored sky. The sun would appear small and distant, the light soft. The chemistry there is complex. Organic molecules form in the upper atmosphere and drift downward like slow snow. It is not Earth, and yet it carries familiar patterns: clouds, rain, rivers, lakes. Nature repeats its shapes under different conditions. You don't need to hold the chemical details. You can simply rest with the idea that even in the outer solar system, far from warmth, there are shorelines. There are cycles. There is weather moving quietly across an alien sea. Comets travel in long, elongated orbits. Many originate in the distant Oort cloud, perhaps tens of thousands of astronomical units from the Sun. They are icy bodies, composed of frozen gases, dust, and rock, remnants from the early solar system. For most of their existence, comets remain far from warmth, moving slowly through deep cold. But occasionally, gravitational nudges send one inward. As it approaches the Sun, heat causes its ices to sublimate, turning directly from solid to gas. This releases dust and gas into space, forming a glowing coma and often a tail that stretches millions of kilometers. The tail does not trail behind the comet like hair in wind. It points away from the Sun, shaped by solar radiation and the solar wind. After passing through the inner solar system, many comets retreat again into darkness, continuing their long arcs that may take thousands or even millions of years to complete. Halley's Comet, for example, returns roughly every 76 years. It was visible in 1986 and will return again in 2061. One object tracing a path that outlives generations. You may imagine a comet drifting inward, brightening gradually, then fading as it recedes. Not hurried, not purposeful, just following gravity's curve. Even when it disappears from view, it continues. Its orbit is not erased by distance. And if some part of your attention drifts away from this description, that's natural too. Orbits can carry things out of sight without ending their motion. The solar system holds both brief appearances and long absences. Both are part of the same path. On Earth, we experience eclipses because of precise alignments. The Moon is about 400 times smaller in diameter than the Sun. It is also about 400 times closer to us. This near coincidence means that, from Earth, the Moon and the Sun appear almost exactly the same size in the sky. When the Moon passes directly between Earth and the Sun, it can block the Sun's light completely, creating a total solar eclipse. The sky darkens. Stars become visible. The Sun's outer atmosphere, the corona, glows faintly around the Moon's silhouette. These alignments are temporary in the grand scale. As the Moon slowly moves away from Earth, centimeter by centimeter each year, total eclipses will eventually become impossible. The Moon will appear slightly too small to fully cover the Sun. But for now, we live in a time when the geometry still works. Eclipses are not disruptions of motion. They are expressions of it. The Moon continues its orbit. Earth continues its rotation. The Sun continues to shine. For a few minutes, shadows align. You don't need to witness an eclipse to feel its quiet precision. Three bodies moving in space, distances balanced just so, creating a temporary dimming of daylight. Alignment does not last, but it returns again and again as long as the orbits continue. If your thoughts occasionally line up, moments of clarity between longer stretches of drifting, that too is part of a larger motion. Nothing in the solar system stays fixed in perfect symmetry, but patterns recur. Ceres, the largest object in the asteroid belt, is round because its gravity is strong enough to pull it into a spherical shape. It contains water ice beneath its surface. Bright spots observed within its Occator crater are deposits of sodium carbonate, salts left behind as briny water reached the surface and sublimated away. Ceres may once have had a subsurface ocean. Even now, it may hold pockets of liquid beneath insulating layers. It orbits the Sun every 4.6 Earth years. It rotates once every 9 hours. It is neither fully planet nor simple rock. It exists in between categories. You may imagine it as a quiet gray sphere, marked with craters and faint reflective patches, circling steadily between Mars and Jupiter. Not all objects need grand titles to matter. Some simply persist in their place, maintaining their orbit without demand for recognition. Ceres does not hurry to become something else. It does not resist its classification. It turns, it circles, it remains. And as you rest here, whether fully awake or drifting at the edge of sleep, the solar system continues in its patient choreography. Mercury warms and cools. Titan gathers methane rain. Comets arc inward and outward. Eclipses align and separate. dwarf planets circle quietly between larger worlds. You do not need to memorize any of it. It is enough that these things are real. It is enough that they move. And it is enough that, for this moment, you are here, gently sharing space with them in thought, or letting the thought fade entirely. The sun does not sit perfectly still at the center of the solar system. It might feel that way in simple diagrams, a bright circle in the middle, planets tracing neat ellipses around it. But in reality, the sun also moves. Every planet exerts a gravitational pull on it. Jupiter, being so massive, influences the sun the most. Instead of remaining fixed, the sun and Jupiter both orbit a shared center of mass called a barycenter, which often lies just outside the sun's visible surface. This means that the sun performs a slow, gentle wobble. Over years and decades, it shifts slightly in response to the planets circling it. Astronomers measure these stellar wobbles in distant stars to detect exoplanets. A star's tiny movement can reveal the presence of unseen worlds tugging at it. In that sense, our own sun is part of the same quiet dance observed across the galaxy. You don't need to picture the geometry precisely. It's enough to imagine that even the central star participates in relationship. Gravity is mutual. Nothing in the solar system is truly stationary. The sun glows steadily, yes. It anchors the system with its mass, and yet it also responds. It shifts. It yields slightly to the presence of its planets. There is something comforting in that. Even the largest body here is not isolated. Even the brightest center moves gently in response to others. If parts of this idea blur, barycenter, wobble, mutual pull, that's fine. The essence is simple. Motion is shared. Influence flows in more than one direction, and all of it happens without noise. Europa, one of Jupiter's largest moons, is covered in ice. Its surface is smooth and bright, streaked with long reddish lines that trace fractures across a frozen shell. Beneath that shell, scientists believe there is a global ocean of liquid water. This ocean may be tens to hundreds of kilometers deep, kept from freezing by tidal heating. As Europa orbits Jupiter, the immense gravity of the planet stretches and compresses the moon slightly. This flexing generates internal heat, much like bending a paperclip back and forth warms it. That heat may maintain liquid water beneath the ice. The ocean is hidden from direct view, but evidence comes from magnetic measurements and surface features observed by spacecraft. The ice appears to shift and refreeze. Some regions look like broken plates that have moved and settled again. You might imagine a dark ocean beneath a thick, frozen crust. No sunlight reaching it. Pressure immense. And yet, possibly liquid, possibly active. Europa orbits Jupiter every 3.5 days, always showing the same face to its planet. Jupiter would loom enormous in its sky. The idea of an ocean hidden beneath ice can feel quiet and mysterious, not dramatic, just concealed. If your thoughts feel layered tonight, surface impressions above deeper currents, that is a gentle parallel. Not everything needs to be visible to exist. Beneath Europa's frozen exterior, motion may continue. And that possibility has rested there for billions of years. Mars has seasons. They are longer than Earth's because Mars takes about 687 Earth days to orbit the Sun. Its axis is tilted by about 25 degrees, similar to Earth's 23.5-degree tilt. This tilt creates seasonal changes in sunlight across its hemispheres. In winter, Carbon dioxide in the Martian atmosphere freezes directly onto the poles, forming seasonal ice caps. In spring, that carbon dioxide sublimates, turning from solid to gas, thinning the polar frost and sending winds sweeping across the planet. Dust storms sometimes rise and spread. Some remain local, others grow to envelop the entire planet, softening its features beneath a veil of suspended particles. These global storms can last for weeks, and yet, after the dust settles, the surface reemerges. Valleys, volcanoes, craters, the same patient landscape beneath. Mars rotates once every 24.6 hours, very close to an Earth day. If you were there, the length of daylight would feel familiar. The sun would rise and set at a pace not unlike what we know. It is easy to think of Mars as static and silent, but it breathes in its own way. Carbon dioxide freezing and thawing, dust lifting and falling, seasons shifting slowly under a pale sky. You don't need to map the hemispheres in your mind. You can simply rest with the idea that another world experiences winter and spring, not identical to ours, but rhythmic. Cycles are not exclusive to Earth. They appear wherever tilt and orbit combine. And if your own energy rises and falls, expands and contracts gently, that too is part of being in motion around something steady. The rings of Saturn are not permanent. Though they appear timeless, scientists believe they may be relatively young, perhaps only hundreds of millions of years old, and they may slowly disperse over time. Tiny particles within the rings are influenced by Saturn's magnetic field and by micrometeorite impacts. Some material gradually spirals inward, falling into the planet's atmosphere as what researchers call ring rain. Water ice and dust drift down along magnetic field lines, subtly altering Saturn's upper layers. This process is slow, measured, not visible without instruments. Each fragment in the rings orbits independently. Collisions occur, but at relatively low speeds, allowing particles to bounce and continue their paths. The structure appears solid from far away, yet up close, it is dynamic, ever adjusting. You might imagine a field of ice fragments circling in quiet sunlight, each one following gravity's curve, occasionally touching, separating again, drifting inward over immense stretches of time. Nothing there is fixed forever, but nothing collapses suddenly either. Change in the solar system often happens on scales so long that it feels like stillness. If something in your awareness feels like it is gently dissolving tonight, an image, a thought, that too can be soft, gradual, without urgency. Saturn's rings will thin one day, but not tonight, not for many generations. They continue their arc in silence. Far beyond the planets lies the heliosphere, a vast bubble created by the solar wind. The sun continuously emits a stream of charged particles. These particles flow outward in all directions, forming a region of influence that extends far past Pluto. This bubble pushes against the interstellar medium, creating a boundary where solar wind pressure balances with the pressure of space beyond. Voyager 1 and Voyager 2, launched in 1977, have crossed this boundary. They now travel through interstellar space, carrying small golden records that contain sounds and images from Earth. The heliosphere is not visible to the eye. It is defined by fields and particles, but it marks the region where the sun's influence dominates. You may picture it as a gentle sphere of wind, expanding outward, holding the planets within its reach. Even at great distances, the the sun's presence extends. And yet beyond that boundary, the galaxy continues. Stars orbit the Milky Way's center over hundreds of millions of years. Our entire solar system moves together through that larger rotation. You don't need to trace those enormous paths. It's enough to know that we are not drifting aimlessly. We follow a curve shaped by gravity on scales almost beyond comprehension. The solar system is nested inside larger structures, like a small current within a vast ocean. If your thoughts widen briefly, imagining distance, imagining layers of motion, you can let them widen. And if they narrow again, that is equally natural. The heliosphere hums quietly, with particles streaming outward. The voyagers continue forward, slowly, steadily. Planets orbit. Moons turn. Ice shifts beneath frozen crusts. And you, resting here, are carried along with Earth's rotation, whether you notice it or not. There is no effort required to be part of this motion. It is already happening. There is a place in the solar system where a spacecraft once landed on a comet. In 2014, the European Space Agency's Rosetta mission released a small lander named Philae onto the surface of comet 67P/Churyumov-Gerasimenko. The comet itself is only about 4 kilometers across at its widest point, shaped somewhat like 2 rounded lobes joined together. Its gravity is extremely weak. If you stood there, carefully, your weight would be almost nothing. A gentle push could send you drifting upward. Philae actually bounced when it first touched down, because the surface was harder than expected, and the harpoons meant to anchor it did not fire properly. It rose slowly, almost gracefully, before settling again. Comet 67P orbits the Sun every 6.4 years. For much of that time, it travels far from warmth, its ices frozen solid. As it approaches the inner solar system, sunlight begins to warm it, and jets of gas and dust stream outward from its surface. Rosetta observed these jets forming, brightening, fading. The comet was not static. It responded to proximity, to heat, to light. You might imagine standing on such a world, a small, irregular body moving quietly through space. The sun small in the sky, dust rising gently from cracks, the horizon curving sharply because the world itself is so small. Even something so modest in size can carry complexity. Organic molecules were detected there, patterns of erosion, subtle changes over time. And if your awareness feels light tonight, almost unanchored, that's all right. Gravity varies across the solar system. Some places hold tightly, others barely pull at all. Comets travel long arcs, sometimes unseen for decades, then briefly illuminated, then gone again. Their journeys are not dramatic in space. They are long and patient. And sometimes, for a short while, we visit them. Jupiter's moon Io is the most volcanically active body in the solar system. More than 400 active volcanoes have been identified on its surface. Plumes of sulfur and sulfur dioxide rise hundreds of kilometers above the moon before falling back down as frost. The reason is tidal heating. Io orbits close to Jupiter, and its orbit is slightly elliptical. As it moves closer and farther from the planet during each 1.8-day orbit, Jupiter's gravity flexes Io's interior. That constant stretching and compressing generates heat within the moon's rocky layers. The result is ongoing volcanic activity, lava lakes, flowing plains, a surface constantly reshaped. And yet, from a distance, Io is simply another small sphere circling a larger one. Its intense internal motion is not visible without close observation. If you were near it, you would see bright yellows and oranges staining the landscape, sulfur compounds reflecting sunlight, dark lava spreading across plains. But in the silence of space, none of this erupts with sound. There is no roar, no crack of thunder, just material moving under gravitational influence. The solar system holds both frozen oceans and molten interiors. Stillness on the outside, activity within. If you ever feel composed on the surface while something energetic moves beneath, that pattern exists in nature too. A calm exterior does not exclude inner heat. Io circles steadily. Jupiter looms large in its sky. The tides continue their pull. And the volcanoes rise and fall without needing to be heard. Earth's orbit is not a perfect circle. It is an ellipse, slightly stretched. The difference between its closest approach to the Sun and its farthest distance is about 5 million kilometers. In January, Earth is actually a little closer to the Sun than it is in July. Seasons are not caused by this change in distance. They arise from Earth's axial tilt, about 23.5 degrees. As Earth orbits the Sun, different hemispheres lean toward or away from sunlight. But that small variation in distance is real, measurable. Earth's path is not rigidly circular. Johannes Kepler described these elliptical orbits in the early 17th century, refining earlier models of planetary motion. He discovered that planets sweep out equal areas in equal times, meaning they move slightly faster when closer to the Sun and slightly slower when farther away. You don't need to follow the geometry precisely. It's enough to know that Earth's journey is subtly uneven. Slightly nearer, slightly farther, slightly faster, slightly slower. Perfection in space is rare. Motion tends toward balance, but not rigid symmetry. The ellipse repeats year after year without strain. A gentle stretch and return. If you're up, Earth continues its orbit. The tilt remains. Light shifts gradually across hemispheres, and all of it unfolds without effort on your part. In the outer solar system, there are objects called trans-Neptunian objects, icy bodies that orbit beyond Neptune. One of them, named Sedna, follows an especially distant and elongated path. Its existence suggests that the outer boundaries of the solar system are shaped by influences we are still uncovering. Perhaps passing stars long ago perturbed its orbit. Perhaps unseen distant objects exert subtle gravitational effects. But Sedna itself does not hurry to reveal its secrets. It moves slowly along its vast arc. If you try to imagine 11,000 years, your mind might drift. That's natural. Human lifetimes are brief by comparison. Sedna has likely completed only a few dozen orbits since the solar system formed. You may picture it as a faint, reddish sphere, traveling through darkness so deep that sunlight is barely more than a bright star. And yet, it remains bound to the Sun. Even at that distance, gravity extends its reach. The idea that influence can stretch so far, nearly a light year in some estimates of the Oort cloud, can feel expansive. But you do not need to stretch your thoughts that wide. You can simply rest with the idea that some paths are very long. Some returns take millennia. Patience is written into orbital mechanics. The Sun itself rotates. Because it is made of plasma rather than solid rock, different parts rotate at different speeds. Near the equator, the Sun completes one rotation in about 25 Earth days. Near its poles, rotation takes closer to 35 days. This differential rotation twists the Sun's magnetic field over time. Magnetic lines tangle and reconnect, producing sunspots and occasional solar flares. Sunspots appear as darker patches on the surface, regions slightly cooler than their surroundings, though still extremely hot by human standards. They follow an approximately 11-year cycle of increasing and decreasing activity. And yet, even during more active phases, the sun's overall energy output remains remarkably stable. The fluctuations are small compared to the steady fusion in its core. You might imagine the sun turning slowly, its surface shifting subtly, magnetic loops arching high above it, light streaming outward, heat traveling across space. The star at the center of our system is not static, but neither is it volatile in a way that disrupts our days. It breathes magnetically, in cycles. If your own rhythms rise and fall over months or years, that too reflects a natural oscillation. Not constant intensity, not constant quiet, but a cycle. The sun rotates. Its poles and equator move at different rates. Magnetic patterns evolve, and still, it shines. Around it, planets continue their paths. Distant objects follow arcs thousands of years long. Moons warm under tidal strain. Comets shed dust in sunlight. You do not need to track all of this motion. You are already within it. Earth turns gently beneath you. The solar system carries on in wide, patient curves. And whether you are listening closely, drifting lightly, or already halfway into sleep, the planets will keep moving just the same. There is a point in space between two large bodies where gravity balances in a quiet way. These are called Lagrange points. When a smaller object orbits along with two larger ones, like Earth and the Sun, there are 5 positions where the gravitational pulls and orbital motion create a stable arrangement. At these points, a spacecraft can remain in a relatively steady position with minimal fuel. One of these, called L2, lies about 1.5 million kilometers beyond Earth, opposite the Sun. The James Webb Space Telescope orbits near this point. It is not parked rigidly in one place, but it loops gently around L2 in a controlled path, always keeping Earth and the Sun in roughly the same direction behind its large sun shield. This arrangement allows the telescope to remain cold and stable, its instruments protected from direct sunlight. You might imagine this as a place of balance, not because gravity disappears, but because forces align. The Sun pulls, Earth pulls, motion curves just so. And in that subtle equilibrium, a spacecraft can hover. Lagrange points exist around many planetary systems. They are not rare. They are mathematical consequences of motion and mass. If your thoughts feel suspended tonight, not pulled strongly in one direction or another, that can be a gentle state too. Balance does not mean stillness. It means forces quietly countering each other. The Webb telescope drifts in its slow halo orbit. Earth circles the Sun. The Sun continues its steady burn. And somewhere between them, balance holds without effort. Saturn's moon Enceladus is small, only about 500 kilometers across, and bright, covered in fresh ice. Yet from cracks near its south pole, plumes of water vapor and ice particles erupt into space. These geysers were discovered by the Cassini spacecraft. As Enceladus orbits Saturn, tidal forces flex its interior, generating heat. That warmth maintains pockets of liquid water beneath the surface. The water escapes through fissures nicknamed tiger stripes, spraying outward in graceful arcs. Some of this material falls back onto the moon as snow. Some escapes entirely, contributing to Saturn's E-ring, a diffuse ring composed largely of particles from Enceladus. Instruments detected organic compounds and salts within these plumes, suggesting that the subsurface ocean interacts with a rocky core. Where water, heat, and chemistry meet, complexity can arise. But the moon, you might imagine standing far away, watching faint jets glimmer against the dark. A small world, venting its inner ocean into the void. There is something gentle about that image, a hidden sea expressing itself in soft fountains. If parts of your own experience feel contained beneath the surface, that is a natural arrangement. Not everything must erupt dramatically. Some expressions are subtle, some movements are slow. Enceladus continues its orbit every 1.4 days. The plumes continue their cycle. Snow falls softly back onto ice. And Saturn's rings receive a quiet contribution from a moon that glows in reflected light. The asteroid Vesta is one of the largest objects in the asteroid belt, second only to Ceres. It is about 525 kilometers across and has a differentiated interior, meaning that in its early history, it became hot enough for heavier materials to sink toward the center and lighter materials to rise. In that way, Vesta resembles a small planet that never fully formed. Its southern hemisphere holds a massive impact basin called Rhea Silvia, nearly as wide as the asteroid itself. The collision that created it was so powerful that it sent fragments of Vesta into space. Some of those fragments eventually fell to Earth as meteorites. Pieces of Vesta have landed here, crossing millions of kilometers over long spans of time. The Dawn spacecraft orbited Vesta in 2011, mapping its surface in detail. It revealed bright streaks, layered terrain, and signs of ancient volcanic activity. Vesta rotates once every 5.3 hours, a relatively quick spin for its size. You may imagine it as a gray, irregular sphere with a deep basin carved into one side. A survivor of early collisions, still circling steadily between Mars and Jupiter. Even after immense impacts, Vesta did not shatter completely. It remained intact, its gravity holding fragments together. In the asteroid belt, stability often follows disruption. Collisions reshape surfaces, but orbits persist. If something in your life has been marked by impact, subtle or otherwise, that too can coexist with continued motion. Structure may shift, paths may adjust, but orbit can continue. Vesta circles the Sun every 3.6 Earth years. It has done so for billions of years. And occasionally, a small fragment from its past arrives quietly on Earth, carrying ancient minerals in a modest stone. Neptune's moon Triton orbits in the opposite direction of Neptune's rotation. This retrograde orbit suggests that Triton did not form alongside Neptune, but was likely captured from the Kuiper belt long ago. It may once have been a dwarf planet traveling independently before gravity drew it in. Triton is cold, around -235 degrees Celsius, yet it displays signs of activity. Nitrogen geysers have been observed erupting from its surface, driven by seasonal heating of its thin atmosphere. Because Triton orbits so close to Neptune and in the opposite direction, tidal interactions are gradually causing its orbit to decay. In billions of years, Triton may break apart, forming a ring around Neptune. But that future lies far beyond any immediate horizon. For now, you might imagine it as a pale sphere crossing Neptune's sky backward relative to the planet's rotation. Not wrong, just different. Capture does not erase identity. Triton retains its composition, its structure, its slow geysers. It moves within a system it once approached from afar. If you ever feel as though you entered a situation from outside, orbiting differently at first, that too has precedent in space. Not everything forms together. Some things join later and find stability nonetheless. Triton continues its retrograde path. Neptune's winds blow across a deep blue atmosphere. The outer solar system remains spacious and cold, and yet, even there, movement persists. Far beyond Pluto, beyond Sedna, perhaps extending nearly a light year from the Sun, lies the hypothesized Oort cloud. It is not directly observed in full, but its existence is inferred from the orbits of long-period comets. The Oort cloud may contain trillions of icy bodies loosely bound to the Sun, forming a vast spherical shell. At such distances, the Sun would appear as a particularly bright star, but no longer dominant in the sky. Gravity there is gentle, yet still present. Passing stars, galactic tides, and distant interactions can perturb objects within the Oort cloud, sending some inward toward the inner solar system. Most, however, remain in distant, slow motion. Their orbits may take millions of years. You don't need to picture the entire sphere. It is too large for easy visualization. Instead, you might hold a simpler image. The Sun's influence extending outward far beyond the planets, thinning gradually, but not vanishing abruptly. The solar system does not end at a sharp boundary. It fades into interstellar space. The Oort cloud represents a kind of outer memory, remnants from the system's formation stored at the edges. If your thoughts feel diffuse tonight, scattered at the periphery, that too can be part of a larger structure. Gravity reaches far, influence lingers, and even at immense distances, objects remain loosely connected to the same star. Closer in, the inner planets continue their shorter orbits. Earth turns, the Moon drifts slightly farther each year. Jupiter tugs gently at the Sun. The solar system is layered, dense near the center, sparse at the edges, and you are resting somewhere within that layered motion, carried along without needing to guide any of it. The planets do not require supervision. The comets do not require memory. They move whether you follow them or not. You can let your awareness soften. You can let the details blur. Gravity continues its quiet work across space, and the solar system remains, patient and wide, around you. There are places on Mars where the ground seems to remember water. Long valleys curve across its surface, branching like river systems seen from above on Earth. These channels were carved billions of years ago, when liquid water likely flowed more freely under a thicker atmosphere. Orbital spacecraft have mapped these networks in careful detail, tracing their paths across cratered plains. Some valleys are wide and smooth, suggesting sustained flow. Others appear sudden and catastrophic, as though formed by rapid floods released from underground reservoirs. In certain craters, dried delta formations remain, fan-shaped deposits of sediment where water once slowed and spread. The Perseverance rover now explores Jezero Crater, a place chosen because it once held a lake. The rocks there contain minerals that form in the presence of water. Layered sediments suggest time passing, particles settling slowly at the bottom of a calm body of liquid. You might imagine that lake under a pale, ancient sky. Not dramatic, just water collecting, reflecting sunlight, perhaps rippling under gentle wind. Mars today is cold and dry. Its atmosphere is thin, and surface water cannot remain liquid for long. But the evidence of its past is written into stone. Planets change, conditions shift. What was once flowing can freeze or fade. If parts of your own life feel like sediment, layers resting quietly beneath the present, that pattern also belongs to planetary history. Not everything disappears without a trace. Some things leave gentle impressions. Mars continues its orbit. Dust drifts across old riverbeds, and rovers move slowly, examining rocks that have waited billions of years to be seen. Jupiter's Great Red Spot has been observed for more than 3 centuries. It is a storm, an anticyclonic vortex, rotating counterclockwise in the planet's southern hemisphere. Wind speeds within it can exceed 400 kilometers per hour. It is large enough to engulf Earth, though in recent decades it has slowly shrunk. The storm persists because Jupiter lacks a solid surface to interrupt it. Beneath its clouds lies deep atmosphere, layers of gas extending downward into increasing pressure and heat. Energy rises from the planet's interior, fueling motion in the upper layers. Jupiter emits more heat than it receives from the Sun. That internal energy helps sustain its dynamic weather systems. The Great Red Spot drifts slightly in latitude over time. Its color varies in intensity. Smaller storms occasionally merge with it, altering its shape. And yet, from a distance, Jupiter appears serene, striped, luminous, composed. You might imagine watching the storm from afar, seeing it rotate steadily within bands of cream and rust-colored cloud. No thunder reaches you. No wind presses against your skin. Just a vast oval turning in silence. Longevity does not require stillness. A storm can persist not by resisting motion, but by participating in it. If something in your life has circled for a long time, an idea, a feeling, that too can be understood as motion within a larger system. Not fixed, not rigid, but sustained. Jupiter turns every 10 hours. The storm turns within it. Heat rises from below, and the planet continues along its 12-year orbit, untroubled by the centuries we use to measure it. Mercury has water ice. This may seem unexpected, given its proximity to the Sun, but radar observations and spacecraft measurements have confirmed deposits of water ice in permanently shadowed craters near its poles. Because Mercury's axis is tilted very little, less than 1 degree, certain crater floors never receive direct sunlight. In these regions, temperatures remain extremely low, even while areas just a few kilometers away blaze with heat. Comets and water-rich asteroids likely delivered this ice long ago. In shadow, it persists. Imagine that contrast. Scorching plains where metal would glow red, and nearby hollows where ice rests quietly in darkness. The solar system often arranges extremes side by side. You might picture standing at the edge of one of those craters. Sunlight glaring above the rim, deep shadow below. Within that shadow, frozen water undisturbed for millions of years. Mercury's rotation is slow, its orbit quick. Sunrises there linger. Even in harsh conditions, pockets of preservation can exist. If part of your mind feels bright and active, while another part rests cool and still, that coexistence is not unusual. Temperature varies across terrain. Ice does not demand warmth to justify its presence. It simply remains where conditions allow. Mercury circles the Sun every 88 Earth days. The polar craters keep their darkness, and within that darkness, water waits. Saturn's rings cast shadows on the planet. As Saturn orbits the Sun over nearly 29.5 Earth years, the angle of sunlight shifts. During certain times, the rings tilt toward the Sun, glowing brightly and casting curved shadows across Saturn's cloud tops. At other times, the rings appear edge-on from Earth, becoming thin lines of light. These changing perspectives remind us that our view depends on position. The rings themselves are composed largely of water ice. Their brightness comes from reflecting sunlight. Their gaps are shaped by gravitational interactions with moons. From Saturn's upper atmosphere, the rings would appear immense, arching across the sky. Their shadows would move slowly with the planet's seasons. You might imagine standing on a hypothetical floating platform within Saturn's clouds, purely in thought, watching the rings sweep overhead. A pale band dividing the sky, a shadow stretching gently across swirling atmosphere. No sound, no urgency. Perspective shifts gradually. What seems broad and luminous from one angle becomes thin and subtle from another. If your current view of something feels different than it once did, that may be a function of position, not of essence. Saturn continues its slow revolution around the Sun. The rings maintain their orbit. Shadows slide across cloud tops in patient arcs. Light changes. Structure remains. The Sun will one day change too. In about 5 billion years, after exhausting the hydrogen in its core, it will expand into a red giant. Its outer layers will swell outward, possibly engulfing Mercury and Venus, perhaps even reaching Earth. But that future is distant beyond comprehension on a human timescale. For now, the Sun remains in its stable phase, fusing hydrogen into helium in a steady equilibrium between gravitational pressure inward and radiation outward. Stars live long lives compared to the creatures orbiting them. You don't need to imagine the red giant stage vividly. It is enough to know that stars evolve. They are not static lanterns, but long-lived processes. The Sun has already shone for 4.6 billion years. It will continue for billions more. Right now, it provides consistent warmth and light. Earth's climate systems, ocean currents, and photosynthesis all depend on that stability. If something feels enduring in your own life, steady and reliable, it may not be eternal, but it can still be deeply real in the present. The Sun holds itself in balance through immense pressure and heat. Gravity pulls inward, fusion pushes outward. The two forces meet in equilibrium. Balance does not require the absence of force. It arises from opposing forces aligning. The star at the center of our system embodies that quiet tension resolved into radiance. And as you rest here, perhaps drifting more now, that radiance continues its journey outward. 8 minutes from the Sun to Earth, thousands of years from the core to the surface, billions of years of stable shining. Planets turn, moons orbit, ice persists in shadow, storms rotate in gas giant skies, ancient riverbeds remain etched in Martian stone. The solar system holds memory and motion at once. You do not need to hold all of it in mind. You can let the details soften. You can let the images blur at the edges. The planets will continue their paths. The rings will cast their shadows. The Sun will rise tomorrow without asking whether you were awake to hear about it tonight. Earth is not alone in having auroras. Jupiter has auroras. Saturn has auroras. Even Uranus and Neptune have auroras, though they are harder to see from such distances. On Earth, auroras form when charged particles from the solar wind are guided by our magnetic field toward the poles. There, they collide with atoms in the upper atmosphere, causing those atoms to glow. Oxygen produces green and red light. Nitrogen contributes blues and purples. Jupiter's auroras are far more powerful. Its magnetic field is the strongest of any planet in the solar system. Charged particles come not only from the solar wind, but also from its volcanic moon Io, which releases sulfur and oxygen ions into space. These particles become trapped in Jupiter's magnetic environment, spiraling along field lines and striking the upper atmosphere near the poles. The result is a constant oval of light, glowing in ultraviolet and infrared wavelengths. Unlike Earth's auroras, which can come and go with solar activity, Jupiter's auroras are nearly continuous. You might imagine standing far away, watching the poles of a gas giant shimmer faintly against dark space. No crackling sound, no cold wind on your face, just charged particles meeting atmosphere, releasing light. Magnetic fields are invisible. They extend outward, shaping motion in ways we do not directly see. If something in your life feels unseen but influential, like a quiet force guiding your thoughts, that too has a parallel in planetary physics. The sun releases particles. Magnetic fields redirect them. Atmospheres glow softly in response, and the dance continues, whether anyone is watching or not. Venus has mountains and plains hidden beneath thick clouds. The surface temperature averages around 465 degrees Celsius, hot enough to melt lead. This heat is caused by a runaway greenhouse effect. Sunlight enters the atmosphere, warms the surface, and the thick blanket of carbon dioxide traps the outgoing heat. Venus rotates slowly and retrograde, taking 243 Earth days to complete one rotation. Its thick atmosphere circulates much faster, with winds high in the clouds racing around the planet in just a few days. So there are two motions there: the slow turn of the solid planet and the swift super-rotation of its atmosphere above. You might imagine descending through layers of cloud, each one opaque and golden, until reaching a rocky landscape beneath. Lava flows hardened long ago, mountains rising under a hazy sky. Despite the extreme heat, the surface remains structured. Craters, ridges, plains. Even in harsh conditions, geology persists. If your thoughts feel layered tonight, surface movement above slower foundations, that layered motion exists elsewhere too. Fast winds above, slow rock below. Venus continues its orbit every 225 Earth days. Clouds swirl. The ground remains unseen but present. Not everything needs to be visible to exist. The Kuiper Belt is a region beyond Neptune filled with icy bodies. It extends from about 30 to perhaps 50 astronomical units from the Sun. Within it orbit Pluto, Haumea, Makemake, and countless smaller objects. These are remnants from the early solar system, preserved in cold storage far from strong solar heating. Haumea is elongated, spinning so rapidly, once every 4 hours, that it stretches into an oval shape. Makemake is reddish, coated with complex organic molecules altered by radiation. Pluto has nitrogen glaciers slowly flowing across its surface, reshaping terrain over long periods. These distant worlds move slowly in their wide orbits. Pluto takes 248 Earth years to complete one revolution around the Sun. Haumea's year is even longer. Sunlight there is faint, about 1,000th the intensity we receive on Earth. Yet it is enough to create shadows, to define shape, to drive subtle seasonal changes. You might picture a small, icy world drifting in deep, blue-black space. The Sun, a bright star, not overwhelmingly luminous. Distance does not erase structure. It simply softens. If your own attention feels far away from the center tonight, distant from urgency or brightness, that distance can be gentle. The Kuiper Belt objects do not rush inward. They maintain their paths, held by gravity's long reach. Out beyond Neptune, motion continues quietly, almost unobserved. Saturn's moon Mimas has a crater so large it nearly split the moon apart. The crater, named Herschel, spans about 130 kilometers across, nearly 1/3 the diameter of the moon itself. The impact that formed it must have been immense. Shockwaves likely traveled through the interior, fracturing rock and ice. And yet Mimas remained intact. Its surface is heavily cratered, giving it a textured appearance. It orbits Saturn every 22 hours, locked so that the same face always points toward the planet. From a distance, Mimas looks serene, a pale sphere with one dominant scar. You might imagine standing on its surface, looking up at Saturn, filling much of the sky, rings arching above. The great crater behind you, walls rising steeply. Even dramatic events can settle into stillness over time. The impact that carved Herschel happened long ago. Now it is simply part of the landscape. Scars in the solar system do not always fade. Sometimes they remain visible, incorporated into structure. If you carry marks from past impacts, visible or not, that too is part of a broader pattern. Stability can return after disruption. Mimas continues its orbit. Saturn's gravity holds it close. The crater rests in quiet sunlight, and space remains silent around it. Earth's magnetic field slowly changes. The magnetic poles wander over time, drifting across the surface of the planet. Geological records show that Earth's magnetic field has reversed many times in its history, north becoming south and south becoming north. These reversals occur over thousands of years. They are not sudden flips in a single day. During a reversal, the field weakens and reorganizes before strengthening again in the opposite orientation. The magnetic field arises from motion within Earth's liquid outer core, molten iron circulating due to heat escaping from the interior. This geodynamo generates the field that shields us from much of the solar wind. You might imagine, deep beneath your feet, thousands of kilometers down, iron flowing slowly in vast currents. No light reaches there, no human sound, just convection driven by heat and rotation. Above, compasses respond to the field. Auroras shimmer near the poles. Satellites adjust their instruments. Change at the core does not immediately disturb the surface. If something fundamental shifts gradually within you, subtle, unhurried, that does not require alarm. Planetary fields reorganize across millennia. Earth continues its rotation every 24 hours. It continues its orbit every year. The magnetic poles wander gently. The solar wind flows outward from the sun. Magnetic lines curve around the planet. Invisible forces shape visible effects. And you, resting here, are carried along with Earth's spin and its orbit. shielded by a field generated far below. The solar system is full of such layered processes: slow cores, shifting fields, distant ice, persistent storms. None of them demand your attention. They simply continue. And if your awareness is softening now, if details slip away, that is as natural as magnetic poles drifting over centuries. The planets turn whether you follow them or not. The sun shines whether you are awake or asleep. You can rest inside that steadiness. Everything out there keeps moving, gently, without needing you to hold it in mind. There are rocks on Earth that came from Mars. They did not travel here gently. Long ago, asteroids struck the Martian surface with enough force to eject fragments of rock into space. Some of those fragments escaped Mars's gravity entirely and entered independent orbits around the Sun. Over millions of years, a small number of them crossed paths with Earth and fell through our atmosphere as meteorites. Scientists identified their origin by analyzing trapped gas within the rocks, gas that matched the composition of the Martian atmosphere measured by spacecraft. The chemistry told a quiet story of departure and arrival. So in museums, and sometimes in private collections, there are stones that once lay on another planet. You might imagine a piece of basalt resting on a Martian plain billions of years ago. Then an impact. Then a long, silent journey through space. Then entry into Earth's sky, a brief streak of fire, and finally, a landing in desert or ice. Nothing about that journey required intention. It followed physics, momentum, gravity. Material can move between worlds. If you ever feel that parts of you have traveled far, changed environments, crossed distances, that too has a planetary parallel. Matter does not always stay where it began. Mars continues its orbit, Earth continues hers, and occasionally, a small piece of one world comes to rest on another. The solar system is not sealed in compartments. It is connected by trajectories. Pluto's heart-shaped region is called Tombaugh Regio. When NASA's New Horizons spacecraft flew past Pluto in 2015, it revealed a bright, heart-like shape spanning much of the dwarf planet's surface. The western lobe of that heart is a vast nitrogen ice plain called Sputnik Planitia. This plain is remarkably smooth and relatively free of impact craters, suggesting that its surface is geologically young. The nitrogen ice there behaves almost like a very slow-moving glacier. Convection cells form as warmer ice rises and cooler ice sinks, creating subtle polygonal patterns across the surface. Pluto is small, about 2/3 the diameter of Earth's moon, and cold. Surface temperatures hover around -220 degrees Celsius. Yet even there, under faint sunlight, ice can shift gradually. Charon, Pluto's large moon, orbits so closely that the two bodies are tidally locked to each other. They show the same faces to one another, rotating together around a shared center in space. You might imagine standing on the edge of Sputnik Planitia, looking across a pale, frozen expanse under a dark sky. Charon, hanging motionless in one part of that sky, neither rising nor setting. Even in distant cold, motion persists. Slow convection beneath ice, mutual orbits between companions. Pluto was once considered the 9th planet. Now it is categorized differently. But its ice still flows. Its moon still circles. Names change. Classifications adjust. Physical processes continue. If something about how you are described has shifted over time, that does not erase your structure. Pluto remains Pluto, heart and all. Far from the sun, it keeps moving through its 248-year orbit. and its frozen plains rearrange themselves quietly under thin atmosphere. There is a region between Mars and Jupiter where spacecraft have navigated safely through the asteroid belt. Despite common images of dense fields of tumbling rocks, the asteroid belt is vast and mostly empty space. When the Pioneer and Voyager spacecraft passed through it, they did so without encountering swarms of debris. Distances between large asteroids are typically enormous compared to their sizes. The belt contains many objects, but they are spread thinly across millions of kilometers. This sparseness is important. It reminds us that space is mostly space. You might imagine drifting between small rocky bodies, each following its own orbit around the sun. No collisions, no chaos, just long arcs through emptiness. Gravity organizes motion without crowding. Sometimes in your own life, a situation that appears dense from afar turns out to contain more room than expected. The impression of clutter dissolves upon closer approach. The asteroid belt does contain stories of collision, families of fragments sharing similar orbits from past impacts. But even those fragments spread over time, occupying wide regions. Motion does not always mean compression. The spacecraft passed through. The asteroids continued their paths. Jupiter's gravity shaped the boundaries of the belt without closing it. Space remains spacious. Neptune's winds are the fastest measured in the solar system. Despite receiving little solar energy, Neptune's atmosphere hosts storms with wind speeds exceeding 2,000 kilometers per hour. Dark spots appear and disappear over years. Bright methane clouds drift high in the atmosphere. Neptune radiates more energy than it absorbs from the sun. Heat left over from its formation contributes to internal convection. That internal warmth helps drive atmospheric motion. It orbits the sun once every 165 Earth years. A Neptunian year spans generations. From Earth, Neptune appears as a small blue point of light. Only through telescopes and spacecraft have we seen its dynamic weather. You might imagine looking down at a deep blue sphere, faint sunlight illuminating its upper layers. Winds racing silently across its surface. A storm swirling in dark cobalt. Distance can conceal intensity. If something in your life seems calm from the outside, yet carries internal motion, that too is reflected in planetary weather. Neptune does not announce its storms across space. They unfold in silence, far beyond the warmth of the inner planets. And still, it remains in orbit, steady in its path. There is a spacecraft named Voyager 1 that continues to travel outward. Launched in 1977, it has passed beyond the heliosphere, the bubble of solar wind, and now moves through interstellar space. It carries a golden record containing sounds and images from Earth, greetings in many languages, music, natural sounds like wind and waves. Its power source slowly weakens as its radioisotope generator decays. Instruments have been turned off one by one to conserve energy. Eventually, it will fall silent, but its motion will continue. You might imagine that small craft, no larger than a car, moving steadily through darkness. The sun now just another bright star behind it. It does not hurry. It does not adjust course frequently. It simply continues along its path, carrying a quiet record of where it came from. Not all journeys need an arrival. Voyager moves because it was set in motion. Planets orbit because they were set in motion. Comets arc inward and outward because gravity curved their paths. And you too are in motion, carried by Earth's spin, by its orbit, by the galaxy's rotation. You do not need to steer any of it tonight. You can let the spacecraft drift. You can let Neptune's winds blow in distant silence. You can let Pluto's ice shift slowly under dim light. Rocks travel between worlds. Ice flows in frozen plains. Storms turn on gas giants. The solar system is wide and patient, and you are free to rest while it continues, without you having to remember any of it. There is a faint glow in the solar system called zodiacal light. These dust grains come from comets shedding material and from asteroids colliding gently over long stretches of time. The particles are small, often no larger than grains of sand, and they spread throughout the inner solar system, concentrated along the same plane in which the planets orbit. Under dark skies, far from city lights, zodiacal light can be visible to the naked eye. It is subtle. Many people mistake it for distant city glow or the early hint of dawn. You might imagine standing somewhere quiet, looking west after sunset. The sun has slipped below the horizon, but a pale column of light lingers, tapering upward into darkness. That light is not coming from a single object. It is the collective reflection of countless small pieces of dust suspended in space. Individually, each grain is insignificant. Together, they create a visible presence. If your own thoughts feel like scattered particles tonight, small and separate, that too can form a soft glow when viewed from a distance. The solar system contains not only planets and moons, but also fine dust drifting in shared orbit. Light touches it. It answers quietly, and then the sky darkens fully again. Earth's rotation is gradually slowing, not in a way that we notice from one day to the next, but over millions of years, tidal interactions with the moon transfer rotational energy outward, causing Earth's spin to decelerate slightly. Hundreds of millions of years ago, a day on Earth was shorter, perhaps only 22 hours long. Coral fossils and sedimentary records preserve patterns that reveal how many days there were in a year long ago. From those patterns, scientists infer the length of ancient days. As the moon drifts farther away, a few centimeters per year, Earth's rotation lengthens by tiny fractions of a second per century. This slowing is steady, measurable, gentle. You might imagine Earth turning just a little more slowly with each passing epoch. The change, imperceptible in a single lifetime, yet real across geological time. Time itself is shaped by motion. The length of a day is not fixed forever. It evolves alongside the relationship between Earth and Moon. If something in your life feels like it is gradually easing, softening, lengthening, that pattern is not foreign to planetary systems. Nothing here spins forever at the same rate. And yet, even as rotation slows, Earth remains stable in its orbit. Seasons continue. Sunrises still arrive. The moon rises. Tides ebb and flow. Change does not always disrupt. Sometimes it simply adjusts the tempo. The sun produces neutrinos in its core. During nuclear fusion, when hydrogen nuclei combine to form helium, tiny particles called neutrinos are released. These particles interact so weakly with matter that trillions of them pass through your body every second without leaving a trace. They travel outward from the sun's core and escape almost immediately, unlike photons of light, which can take thousands of years to reach the surface. Neutrinos reach Earth in just over 8 minutes, streaming through rock, ocean, atmosphere, and living cells with almost no interruption. Scientists have built vast underground detectors filled with ultra-pure water or other materials to capture the faintest interactions of these particles. Deep beneath mountains or ice, occasional flashes of light reveal that a neutrino has collided with an atom. You might imagine the sun's core, an environment of immense pressure and temperature, quietly producing not only light and heat, but also these nearly intangible messengers. And right now, as you rest, neutrinos from the sun are passing through you. You do not feel them. They do not warm or cool you. They simply move. There's something calming in that invisibility, forces and particles flowing continuously without demand. The sun continues its fusion. Neutrinos continue their flight. You remain undisturbed. There are regions on the moon where sunlight barely changes. Near the lunar poles, some mountaintops receive nearly continuous sunlight, while certain craters remain in permanent shadow. These areas are of interest for future exploration because they offer both steady solar power and access to ice preserved in darkness. The moon rotates once every 27.3 days, the same time it takes to orbit Earth. This synchronous rotation means we always see the same face from our planet. Yet from orbit, spacecraft have mapped the far side, heavily cratered, rugged, different from the familiar near side. You might imagine standing near the moon's south pole, where the sun skims low along the horizon, casting long, slow-moving shadows. A crater nearby remains dark at its base, holding ice that has not melted for billions of years. Light and shadow coexist in close proximity. The moon does not generate its own light. It reflects the sun's glow. Its surface holds both brightness and darkness, depending on angle and tilt. If your own experience feels partly illuminated and partly obscured tonight, that duality exists naturally in celestial bodies. The moon continues its orbit. Earth continues its spin. Ice rests quietly in shadow. Sunlight traces long arcs across silent terrain. There is a thin boundary called the heliopause, where the solar wind meets interstellar space. Within the heliosphere, the sun's particles dominate. Beyond the heliopause, particles from other stars and the broader galaxy become more prominent. Voyager 1 crossed this boundary in 2012. Instruments recorded changes in particle density and magnetic field orientation, signaling that it had entered a new region. The heliopause is not a solid wall. It is a transition, a place where influence shifts gradually from one regime to another. You might imagine a bubble expanding outward from the sun, meeting the surrounding medium softly. No collision in the ordinary sense, just pressure balancing pressure. Boundaries in space are often like this, not sharp lines, but zones of gradual change. If you find yourself between phases, not entirely in one state or another, that condition is not unusual in the cosmos. The solar system does not end abruptly. It fades into interstellar space. Voyager continues outward, crossing from one domain into another without ceremony. The sun still shines behind it. Planets continue their orbits within the heliosphere. and you remain here on Earth, well inside that protective bubble of solar wind, carried along by motion you do not need to direct. Dust glows faintly after sunset. Days lengthen over epochs. Neutrinos pass through unnoticed. Ice rests in lunar shadows. The sun's influence extends outward and thins. The solar system breathes in quiet processes, large and small. You do not need to remember their names. You do not need to hold their measurements. They continue whether you attend to them or drift away. And drifting is welcome here. The planets are patient. The light is steady. And the motion goes on. There is a slow rain falling into Saturn. It is not rain like we know on Earth. It is made of tiny particles from Saturn's rings, water ice and dust, drawn inward by gravity and guided along magnetic field lines. Scientists call it ring rain. As micrometeorites strike the rings and sunlight charges their particles electrically, some material spirals down into the planet's upper atmosphere. There, it interacts with hydrogen and other gases, subtly changing the chemistry. This process is gradual. It does not empty the rings in a single dramatic cascade. It happens particle by particle, year after year. Saturn's rings appear solid and permanent from afar, but they are part of a system in motion. Material circulates. Some fragments collide and bounce outward. Others drift inward and dissolve into cloud tops. You might imagine the rings arching wide around the planet, brilliant in sunlight, while a faint, invisible drizzle falls along magnetic lines toward the poles. Nothing about it is hurried. Structures that look stable often participate in quiet exchange. If something in your life feels solid, it is slowly transforming in small, almost unnoticeable ways. That too is not unusual. Change can be granular, gradual, nearly invisible from moment to moment. Saturn continues its orbit around the Sun every 29.5 Earth years. Its rings remain luminous, and yet, piece by piece, some of their substance returns to the planet below. There is no rush, only process. The Sun has a sound, not in the way we hear sound in air, because space is a vacuum and cannot carry ordinary sound waves. But within the Sun itself, pressure waves move through its plasma interior. These waves cause the surface to rise and fall slightly in rhythmic patterns. Scientists study these oscillations through a field called helioseismology. By observing subtle vibrations on the Sun's surface, they can infer what is happening deep inside, how fast it rotates at different depths, how temperature and density vary. The Sun rings like a vast instrument with many overlapping tones. If those vibrations were converted into audible frequencies, they would form a low, resonant hum. You might imagine the Sun not as silent, but as gently resonating within itself. Waves moving through plasma, rising and falling in cycles. These oscillations are steady and ongoing. They do not disrupt the Sun's radiance. They are part of its equilibrium. If something within you vibrates quietly, a thought repeating, a rhythm in your breathing, that internal motion need not disturb your outer calm. The Sun's surface ripples in patterns too subtle for the eye, yet they reveal its structure. Even immense bodies carry internal music. And while you rest here, those waves continue, rising and falling in a star nearly 150 million kilometers away. Mars has dust devils. These are small whirlwinds that form when sunlight warms the surface unevenly, causing pockets of rising air. As warmer air ascends, cooler air moves in to replace it, and under the right conditions, rotation begins. Dust devils on Mars can tower kilometers high. They move across the landscape, lifting fine red dust into tall, narrow columns. Because Mars has a thin atmosphere, these whirlwinds are not as forceful as Earth's tornadoes. They are quieter, less destructive. They trace faint lines across the surface, sometimes cleaning solar panels on rovers by brushing away accumulated dust. You might imagine watching one cross a broad plain, twisting gently under a pale salmon-colored sky. No thunder, no crashing debris, just a narrow spiral of dust turning slowly. Even in a world that seems still, small motions arise from simple temperature differences. If a small swirl of thought forms in your mind tonight, rising briefly, then fading, that too is part of a thermal rhythm. Dust devils do not last long. They spin and dissipate. Mars continues its rotation every 24.6 hours. The sun rises and sets there as it does here. Surface winds shape dunes over centuries. Fine particles settle again after each small whirlwind passes. Motion does not always require scale to be meaningful. Sometimes it is delicate. The moon has moonquakes. Though it lacks the plate tectonics that cause earthquakes on Earth, the moon experiences seismic activity. Some moonquakes are caused by tidal forces as Earth's gravity flexes the lunar interior. Others result from thermal expansion as the surface cools rapidly after sunset. During the Apollo missions, astronauts placed seismometers on the moon. These instruments detected vibrations that sometimes lasted longer than similar quakes on Earth. Because the moon is dry and rigid, seismic waves do not dissipate as quickly. You might imagine standing on the lunar surface, feeling a subtle tremor beneath your feet. Not violent, just a gentle shudder passing through rock. The moon appears still from Earth, a steady disk waxing and waning. But beneath that stillness, stress accumulates and releases quietly. Even bodies that seem calm can carry internal adjustments. If something within you shifts slightly, not dramatic, not alarming, that shift can simply be structural settling. The moon continues its orbit every 27.3 days. It remains tidally locked to Earth, showing us the same face. Yet inside, it responds to gravitational pull. Silence does not mean inactivity. Far beyond Neptune, the sun's gravity still holds sway. The outermost comets in the Oort cloud are so distant that their orbits may extend halfway to the nearest star. And yet, mathematically, they remain bound to the sun's mass. Gravity weakens with distance, but it does not vanish abruptly. It fades gradually, extending outward in ever larger spheres. Our solar system itself moves through the Milky Way galaxy at about 220 kilometers per second, completing one orbit around the galactic center roughly every 230 million years. That means Earth has circled the galaxy only about 20 times since it formed. You might imagine this nested motion: Earth orbiting the sun orbiting the galactic center, the galaxy moving within a cluster of galaxies, layer upon layer of motion. You do not feel any of it directly. No wind from the galaxy's rotation, no jolt from Earth's speed. Movement in space can be smooth and continuous, undetectable without instruments. If your own life carries you along in larger patterns you do not always perceive, that too is consistent with cosmic motion. The solar system is not stationary within the universe. It travels quietly through a larger structure, and you are traveling with it. There is no need to track the velocity. No need to measure the distance. You can simply rest while the nested orbits continue. Ring rain falls slowly into Saturn. The sun hums within itself. Dust devils rise and fade on Mars. The moon trembles gently in response to Earth. The Oort cloud drifts at the far edges of the sun's influence, and all of it moves without urgency. If your awareness is softening now, if details are becoming less distinct, that is welcome. The solar system does not require your attention to remain in balance. It continues its patient choreography, whether you follow every step or drift into sleep. You can let it move. You can let yourself rest. Everything out there is steady enough to hold itself. There are tiny grains of sand drifting between the planets. Not metaphorical grains, real ones. Microscopic particles of rock and ice that orbit the sun in wide, flattened paths. Some were released by comets as they warmed and shed material. Others were created when asteroids collided softly, fragmenting over long periods of time. These particles form a thin disk of dust throughout the inner solar system. When sunlight strikes them at the right angle, they create the faint glow we sometimes see as zodiacal light. But most of the time, they go unnoticed. Each grain follows its own orbit, shaped by gravity, radiation pressure, and occasional collisions. Some slowly spiral inward toward the sun, due to a subtle effect called Poynting-Robertson drag, in which sunlight itself exerts a tiny braking force. Light can move dust. You might imagine a single speck, no larger than a grain of flour, circling the sun for thousands of years. No atmosphere brushing against it, no sound, just momentum and gravity holding it in motion. Over time, it drifts slightly inward. Eventually, it may vaporize in solar heat, but until then, it travels quietly. If a small thought passes through your mind tonight, brief and merely weightless, that too can follow a gentle arc before dissolving. Not every particle needs to become a planet. Not every fragment must gather into something larger. Some things simply orbit for a while, and the sunlight continues to fall on them all. Jupiter has faint rings. They are much thinner and darker than Saturn's bright bands, composed mostly of dust ejected from small inner moons like Metis and Adrastea. Micrometeorite impacts strike those moons, lofting fine particles into space. Jupiter's gravity then holds that dust in a diffuse ring system. From a distance, the rings are barely visible. They were discovered only in 1979 by the Voyager 1 spacecraft. You might imagine standing far from Jupiter, looking carefully for a subtle halo around the planet. Not a bold, shining ring like Saturn's, but a faint, dusty band catching light at certain angles. Even massive planets can carry delicate structures. Jupiter itself rotates quickly, once every 10 hours, flattening slightly at its poles due to centrifugal force. Beneath its cloud tops, pressures increase until hydrogen behaves like a liquid metal, conducting electricity and generating a powerful magnetic field. And yet, around this immense world, a thin veil of dust circles quietly. Strength and subtlety coexist. If part of your life feels grand and energetic, while another part feels fine and almost invisible, that layering is not unusual. Not everything needs to shine brightly to be real. Jupiter continues its 12-year orbit. Its faint rings drift around it, replenished by ongoing impacts. And in the quiet between planets, dust keeps circling. There are seasons on Saturn. Though Saturn is a gas giant, It has an axial tilt of about 26.7 degrees, similar to Earth's. As it orbits the Sun over nearly 29.5 Earth years, different hemispheres tilt toward or away from sunlight. This shift changes the angle at which sunlight strikes the rings in the upper atmosphere. During Saturn's equinox, the rings appear almost edge-on from Earth, casting thin shadows. During solstice, they open wide, bright and reflective. The planet's cloud patterns also change subtly with the seasons. In the northern hemisphere, a persistent hexagonal storm system sits at the pole, a six-sided jet stream that has remained stable for decades. You might imagine Saturn drifting along its long orbit, sunlight sliding gradually from one hemisphere to the other, the rings tilting, shadows lengthening and shortening. Nothing abrupt, just gradual change across decades. A full Saturnian year spans nearly 30 Earth years. Many human events begin and end within a single Saturn season. Time feels different at that scale. If something in your life feels like it is unfolding slowly, too slowly to notice day by day, that rhythm exists elsewhere in the solar system. Tilt creates variation. Orbit creates return. Saturn, the hexagon at its pole, rotates calmly, shaped by fluid dynamics rather than intention, and the rings continue to trace their luminous arcs. There are lava tubes on the Moon. When molten rock once flowed across the lunar surface, the outer layers of the flow cooled and solidified, while molten material continued moving beneath. Eventually, the lava drained away, leaving behind hollow tunnels. Some of these tubes may be large enough to house future explorers. Because the Moon lacks weather and erosion, these structures can remain intact for billions of years. Orbiting spacecraft have identified skylights, collapsed sections revealing entrances to these subterranean spaces. You might imagine descending into one of these tunnels. The temperature more stable than on the surface, the silence deeper still. The Moon appears barren from afar, but it contains interior spaces shaped by ancient activity. Even worlds that seem inert carry hidden architecture. If you feel that parts of yourself are unseen, perhaps forming quiet chambers within, that is not unlike a lava tube preserved in shadow. The Moon continues its orbit. Sunlight washes across craters and plains. Beneath, hollow corridors remain. Time does not erase all structure. Far beyond Pluto, the influence of passing stars can disturb distant comets. As our solar system moves through the Milky Way, it occasionally passes relatively near other stars, not close enough for collision, but near enough for gravity to exert a faint tug on the most distant objects in the Oort cloud. These encounters are rare and slow. A star might pass within a few light-years over millions of years. Its gravity could nudge some comets inward, sending them on long journeys toward the inner solar system. The night sky shifts gradually over tens of thousands of years, as stars move relative to one another. Constellations slowly change shape. You might imagine the solar system as a traveler within a larger community of stars, occasionally influenced by neighbors passing at great distance. Nothing collides abruptly. Motion is smooth, continuous. If something external gently alters your path, not dramatically, but subtly, that too can be part of a larger movement. The galaxy is not static. Our Sun orbits its center once every 230 million years, weaving between spiral arms. Planets remain bound to the Sun, even as the entire system travels. Comets rest in deep freeze until nudged into new arcs. And you, here on Earth, are part of that layered motion. Dust drifts in sunlight. Jupiter carries faint rings. Saturn tilts through long seasons. Lava tubes wait in lunar shadow. Distant stars pass without fanfare. The solar system is not a frozen diagram. It is a field of gentle processes unfolding over immense time. You do not need to keep track of all of it. You can let the dust continue its orbit. You can let Saturn's rings tilt toward the sun. You can let distant stars glide past in the background. Everything moves, whether you follow it or not. And you are allowed to rest while it does. There is water vapor in the atmosphere of Jupiter. Not in the same proportions as on Earth, and not forming familiar clouds of rain over solid ground, but present nonetheless. Deep within Jupiter's thick atmosphere, water exists alongside ammonia and methane, forming layers of clouds at different altitudes. When the Juno spacecraft entered orbit around Jupiter in 2016, it carried instruments capable of probing beneath the visible cloud tops. Measurements revealed that water is more abundant near the equator than previously thought, mixed into turbulent bands of rising and sinking gas. Jupiter does not have a surface you could stand on. As you descend, the gas grows denser, transitioning gradually into liquid-like states under immense pressure. Deeper still, hydrogen behaves as a metallic fluid, conducting electricity and contributing to the planet's magnetic field. And yet, within all that pressure and motion, molecules of water drift, condense, and circulate. You might imagine a vast sphere of cloud and storm, where layers overlap and currents intertwine. Lightning has been observed there too, flashes in towering storms, illuminating cloud tops briefly before fading. Water, in one form or another, appears again and again in the solar system, frozen in shadow, locked beneath ice, mixed into gas giants. It does not require oceans to exist. If something in your life takes a different form than expected, not liquid and flowing, but vaporous or suspended, that too is still real. Jupiter continues its rapid rotation, completing a spin every 10 hours. Storms roll, bands shift, water molecules circulate within a world without a solid shore. And none of it makes a sound in space. Mercury has a long memory, written in craters. Because it lacks a thick atmosphere and active plate tectonics, its surface preserves the marks of ancient impacts. Some craters are billions of years old, their rims softened slightly by micrometeorite erosion, but otherwise intact. One of the largest features is the Colorus Basin, formed by a massive collision early in Mercury's history. The impact sent shockwaves through the planet, fracturing the crust even on the opposite side. From orbit, the surface appears densely packed, overlapping circles of different sizes. You might imagine standing on that terrain. A landscape of stone under a black sky, the sun glaring bright and unfiltered above the horizon, shadows sharp and dark. Time there feels still, because the processes that erase surface features on Earth, wind, water, shifting plates, are mostly absent. Not everything in the solar system renews itself quickly. Some surfaces preserve history in open view. If you carry memories that feel etched deeply, not easily worn away, that too reflects a natural pattern. Some marks remain visible because nothing has come along to smooth them. Mercury rotates slowly. Its year is short. Temperatures swing from extreme heat to deep cold. And through it all, its cratered face remains, holding the record of ancient impacts under unchanging stars. There are clouds on Neptune that cast shadows. In 2018 and 2021, astronomers observed bright methane ice clouds forming at high altitudes on Neptune. These clouds drift across the planet's deep blue atmosphere, sometimes appearing near the equator, sometimes near the poles. Because Neptune's atmosphere is dynamic, these clouds can evolve over days or weeks. They are shaped by internal heat rising from below, interacting with colder upper layers. From a great distance, Neptune appears as a smooth blue disk. But closer examination reveals subtle patterns, dark vortices, bright streaks, shifting formations. You might imagine sunlight striking those high-altitude clouds, creating soft shadows on lower layers of gas. Light falling on vapor in a place nearly 5 billion kilometers from the sun. Even there, illumination shapes form. If parts of your experience feel diffuse, like vapor moving across a larger backdrop, that can be gentle. Clouds do not need to become storms to have presence. Neptune completes one orbit every 165 Earth years. Its seasons last decades. High above its deep atmosphere, methane ice condenses and disperses, and the planet continues turning in quiet blue light. The asteroid Bennu is a loose collection of rubble. Explored by NASA's OSIRIS-REx mission, Bennu is classified as a rubble pile asteroid. Rather than being a single solid rock, it is composed of many fragments held together by gravity and weak cohesion. Its surface is strewn with boulders. Some of these rocks were ejected gently into space and later fell back down because of the asteroid's weak gravity. OSIRIS-REx collected a sample of material from Bennu in 2020, touching the surface briefly and capturing dust and pebbles before returning to Earth. Bennu rotates once every 4.3 hours. Its gravity is so slight that a person could leap off its surface with ease. You might imagine standing there, carefully, on a body shaped like a spinning top, rocks loosely arranged, held together just enough to remain whole. Strength does not always come from solidity. Sometimes it comes from collective balance. Fragments can gather and persist without fusing into a single mass. If you ever feel composed of many small pieces, experiences, thoughts, roles, that too is a viable structure. Bennu continues its orbit around the Sun every 1.2 Earth years. Its surface shifts subtly as sunlight warms it and as tiny forces alter its spin over time. It is not rigid. It is assembled, and still, it remains. The sun's light pressure can move objects. Though sunlight feels gentle on skin, photons carry momentum. When they strike a surface, they exert a tiny force. For large bodies like planets, this force is negligible. But for small asteroids or spacecraft, over long periods, it can have measurable effects. This phenomenon, called the Yarkovsky effect, occurs when an object absorbs sunlight and re-emits the energy as heat. The re-radiated heat creates a small thrust, gradually altering the object's orbit. Over millions of years, this subtle push can shift asteroids inward or outward. Light does not only illuminate, it nudges. You might imagine a small rock in space, warmed on one side, slowly drifting in its path because of the faintest imbalance. Change does not always require impact. Sometimes it arises from steady exposure. If something in your life shifts gradually, not from collision, but from constant, gentle influence, that too is natural. The sun shines. Photons travel outward. Small bodies adjust their paths imperceptibly at first. Planets remain largely unaffected. Dust grains respond more readily. Everything exists within a field of forces, some obvious, some nearly invisible. And still, the solar system holds together. Water vapor circulates within Jupiter. Mercury keeps its ancient scar. Neptune's clouds cast faint shadows. Bennu spins as a gathered collection of fragments. Sunlight presses softly against stone. You do not need to remember each detail. They will continue, regardless. You can let the images fade if they wish to. The planets are steady. The sun is patient. The motion carries on without demand, and you are free to rest inside that wide, quiet system, whether awake or already drifting towards sleep. There are storms on Saturn that come and go over decades. One of the most remarkable is called the Great White Spot. Roughly once every Saturnian year, about every 29 Earth years, a massive storm erupts in Saturn's atmosphere. It begins as a bright white cloud that can grow to encircle the entire planet. These storms are driven by seasonal heating and internal energy rising from below. They release enormous amounts of lightning, detected by radio emissions measured by spacecraft. The lightning flashes are thousands of times more powerful than those typically seen on Earth. And yet, from far away, Saturn still appears composed and balanced. Rings extending outward, cloud bands wrapping gently around its sphere. The storm eventually fades. The atmosphere settles. The bright disturbance blends back into surrounding bands. You might imagine watching that bright plume expand across Saturn's upper layers, then slowly soften, then dissolve into the broader pattern. Even large disturbances can integrate back into structure. If something in your own life rises suddenly, intense, luminous, it may not last forever. It can spread, then disperse, becoming part of a wider field. Saturn continues its orbit. Its rings remain luminous. The Great White Spot comes perhaps once in a generation and then retreats. Motion resumes its quieter pace. There are boulders on the moon that have not moved for millions of years. Without atmosphere, wind, or flowing water, the lunar surface changes very slowly. A rock dislodged by an ancient impact may rest exactly where it fell, untouched by erosion. Its edges remain sharp. Its shadow shifts only with the slow progression of lunar day and night. Astronaut footprints left during the Apollo missions remain visible today. There is no weather to wash them away. You might imagine standing on the moon and looking at a rock casting a long shadow under low sunlight. The sky above would be black even at noon. No clouds drifting past. No breeze. Time on the lunar surface feels suspended because the processes that reshape landscapes on Earth are absent. Stillness, in that sense, is preserved. If part of you feels unmoved by time, a memory or a feeling that remains unchanged, that too has a place in the cosmos. Not all surfaces renew. Some simply endure. The moon continues its orbit around Earth. Phases change. Shadows slide slowly across craters, but the boulders remain where they landed. There are lakes of liquid methane on Titan that reflect Saturn's light. Titan's northern hemisphere holds large seas such as Kraken Mare and Ligeia Mare. These are composed primarily of methane and ethane, liquids at Titan's frigid temperatures. When sunlight glances off their surfaces, reflections shimmer faintly. Radar instruments have revealed shorelines and possible wave activity driven by gentle wind. Beneath Titan's thick orange haze, rivers of methane carve channels into icy terrain, forming deltas where they meet the seas. You might imagine standing at the edge of one of those lakes, the air thick and cold, Saturn hanging faintly in the sky behind layers of cloud. The liquid surface dark and mirror-like. Though alien in chemistry, the shapes are familiar. Coastline, horizon, calm water stretching outward. Nature repeats geometry under different conditions. If something in your experience feels familiar yet subtly altered, recognizable but not identical, that too mirrors planetary variation. Titan orbits Saturn every 16 days. Methane evaporates, condenses, and falls as rain in cycles. Even in deep cold, there are tides and shorelines, and the seas remain, reflecting dim sunlight across quiet waves. There are Trojan asteroids that share Jupiter's orbit. These objects cluster around two stable Lagrange points, one leading Jupiter in its orbit around the Sun, and one trailing behind. They are called Trojans because many were named after figures from Greek and Trojan mythology. Held in these gravitationally balanced regions, the asteroids move in synchrony with Jupiter, neither falling inward nor drifting away. Thousands have been identified. Some are tens of kilometers across. They are remnants from the early solar system, preserved in these stable pockets for billions of years. You might imagine them as small companions, traveling alongside Jupiter but at a respectful distance, gathered around points of equilibrium. Balance creates places of quiet persistence. If you have ever found yourself in a position that feels stable, not because nothing moves, but because forces align, that reflects the nature of a Lagrange point. The Trojans do not race ahead or lag behind. They maintain their positions within Jupiter's path. Jupiter continues its orbit every 12 years. The Sun remains at the center. The Trojans circle in shared rhythm. There are ice grains in Saturn's rings that are nearly pure water. Some of these particles are bright enough to reflect sunlight strongly, giving the rings their luminous appearance. Spectroscopic studies show that much of the ring material is composed of water ice, with only small amounts of rocky contamination. These ice grains range in size from micrometers to meters. They collide gently, break apart, recombine. Gravity organizes them into distinct bands, separated by gaps shaped by nearby moons. From a distance, the rings appear solid and serene. Up close, they are a swarm of individual pieces moving in precise orbits. You might imagine drifting among them, watching chunks of ice glide past slowly, sunlight glinting off crystalline surfaces. No sound accompanies their motion, no friction of air. Each particle follows the same central force, yet maintains its own path. Collective structure emerges from individual trajectories. If your own life feels composed of many small movements, each day a separate orbit, that too can form a broader pattern when seen from afar. Saturn turns, its rings shimmer. The ice grains continue circling, reflecting light, colliding softly. Storms bloom and fade in Saturn's clouds. Lunar boulders rest unchanged in vacuum. Methane lakes reflect dim light on Titan. Trojan asteroids travel in balanced clusters. Water ice drifts in rings around a distant giant. The solar system holds both movement and pause, both eruption and endurance. You do not need to catalog them. You can let the images soften at their edges. The planets continue their paths, whether you remember their names or not. The sun rises and sets on worlds you will never visit, and you, here on Earth, are allowed to rest, while all of it carries on in patient silence. There are shadows on Mars that stretch for kilometers. When the sun sits low on the Martian horizon, the long slopes of volcanoes and crater rims cast extended silhouettes across the rust-colored plains. Because Mars's atmosphere is thin and often filled with fine dust, sunlight scatters differently than it does on Earth. The sky can appear butterscotch near the horizon and pale pink overhead. Olympus Mons, the largest volcano in the solar system, casts a shadow so long that from orbit it looks like a dark wedge cutting across the planet's surface. The shadow shifts slowly as Mars rotates, once every 24.6 hours, in a rhythm not so different from Earth's day. You might imagine standing on that distant world at sunrise. The sun small and sharp in the sky, a mountain's outline stretching far across quiet ground. Shadows are evidence of light. They require both illumination and form. On Mars, dust can soften their edges, blurring the boundary between brightness and shade. If something in your life feels like a long shadow, an effect of something larger, that too is a natural interplay between light and structure. Mars continues its orbit every 687 Earth days. Its seasons shift gently with its axial tilt. Mountains remain. Shadows lengthen and recede. The planet turns in silence, carrying both light and darkness across its surface. There are resonances in planetary orbits. Mercury rotates 3 times on its axis for every 2 orbits around the Sun. A 3-to-2 spin-orbit resonance. Pluto and Neptune are locked in a 3-to-2 orbital resonance as well, meaning that for every 2 orbits Pluto makes, Neptune completes 3. This arrangement keeps their paths stable, preventing close encounters, even though their orbits cross in projection. Resonance is not coincidence. It arises from gravitational interaction over long periods, settling into ratios that maintain balance. You might imagine 2 dancers circling a central light, stepping in patterns that repeat reliably over time. These patterns do not require intention. They emerge from physics. If something in your life feels rhythmic, repeating in cycles that seem almost mathematical, that can be a resonance rather than a random event. Planets and moons do not collide because of these stable ratios. They keep time together. Mercury turns slowly under bright sunlight. Pluto drifts along its elongated path. Neptune circles steadily farther out. Ratios hold them in place. The solar system carries its own quiet mathematics. There is frost on Pluto. When New Horizons passed by in 2015, it revealed mountains of water ice rising several kilometers high, and plains covered in nitrogen frost. Methane frost coats some higher elevations, giving them a bright, reflective appearance. Pluto's thin atmosphere expands slightly when it approaches the Sun in its elliptical orbit, then collapses and freezes onto the surface as it moves farther away. Seasonal changes there unfold over decades and centuries. You might imagine standing on one of those icy plains, under a dark sky with the sun shining faintly, frost glinting under distant light. Charon fixed in the sky, unmoving because of tidal locking. Cold does not mean lifeless in motion. Ice can shift, sublimate, condense again. Even on the edge of the solar system, processes continue. If something in your life feels quiet and distant, that does not mean it is static. Subtle cycles can operate beneath apparent stillness. Pluto completes 1 orbit every 248 Earth years. Frost gathers and retreats in patient sequence. The dwarf planet moves without hurry, carrying its heart-shaped plane around the sun. There are magnetic fields around planets that shape invisible boundaries. Earth's magnetosphere deflects much of the solar wind, forming a teardrop-shaped region extending outward from the planet. On the sunward side, the magnetic field compresses. On the night side, it stretches into a long tail. Jupiter's magnetosphere is even larger, so vast that if it were visible from Earth, it would appear larger than the full moon in the sky. These magnetic fields guide charged particles, trap radiation belts, and influence auroras. You might imagine Earth wrapped in a gentle, unseen shield, lines of force curving outward and reconnecting on the far side. Magnetic boundaries are not rigid walls. They shift with solar activity. They pulse and flex. If you feel protected in ways that are not visible, supported by structures you cannot see, that parallels planetary magnetism. The solar wind flows outward from the sun. Magnetic fields respond. Auroras shimmer near the poles, and all of it occurs silently, without requiring awareness. There are craters on Mercury that hold ice, and craters on the Moon that hold ice, and perhaps craters on Mars that once held lakes. Impact shapes landscape across the solar system. Asteroids strike, forming circular depressions. Over time, some fill with lava. Others collect ice in shadow. You might imagine a meteorite entering a thin atmosphere, striking ground, and excavating a bowl-shaped crater. The energy released, immense in the moment, then gone. Afterward, quiet returns. Some craters become places of preservation. On Mercury and the Moon, shadowed interiors protect water ice from sublimating. On Mars, ancient craters once contained lakes that left mineral traces behind. An impact can create both destruction and containment. If something in your life felt like an impact, sharp, disruptive, it may also have formed a basin where something else could gather. The solar system records collisions not only as scars, but as structures. Mercury circles the sun quickly. The Moon orbits Earth steadily. Mars rotates under thin skies. Craters rest under unfiltered sunlight. Ice hides in shadow. Magnetic fields curve invisibly around planets. Resonances keep orbits in balance. Frost glows faintly on distant Pluto. Shadows stretch across Martian plains. You do not need to hold all of this in your mind at once. You can let the images drift apart like asteroids in a wide belt. The planets will continue their resonant steps. The sun will continue its steady fusion. And whether you are awake enough to follow each detail, or already drifting gently toward sleep, the solar system remains patient and wide. You are allowed to rest while it turns. There are places in the solar system where sunrise takes hours. On the Moon, because a full day-night cycle lasts about 29.5 Earth days, the sun rises very slowly over the horizon. It does not leap upward in minutes. It creeps. Shadows shorten gradually. Light spreads across crater rims and into valleys with patient steadiness. If you were standing on a flat plain near the lunar equator, you would watch the sun lift in near silence over the course of many Earth hours. The black sky would remain black even as the ground brightened. On Mercury, sunrise can be even stranger. Because of its 3-to-2 spin-orbit resonance, the sun can appear to pause in the sky, reverse direction briefly, then continue rising again. The interaction between Mercury's slow rotation and quick orbit creates this gentle visual hesitation. You might imagine watching that, A star rising, slowing, stepping back slightly, then proceeding forward. Sunrise does not need to be dramatic to be meaningful. It can be snow enough that you almost forget it is happening. If something in your life is beginning, not with a burst, but with a gradual illumination, that too belongs to planetary rhythms. The moon turns. Mercury turns. Light slides across rock in deliberate motion. You do not need to hurry with them. There are canyons on Mars that stretch for thousands of kilometers. Valles Marineris is one of the largest canyon systems in the solar system. It spans over 4,000 kilometers long and reaches depths of up to 7 kilometers in places. It is not a river-carved canyon like Earth's Grand Canyon, but a tectonic rift, a place where the crust stretched and fractured. Cliffs rise sharply from the canyon floor. Landslides have shaped its walls. In some areas, signs of past water activity appear in layered sediments. From orbit, it looks like a vast scar across the Martian surface. From the ground, it would feel like a horizon lined with towering rock. You might imagine standing near its edge, looking across a chasm under a dusty salmon sky. The air thin, the wind soft. Scale there is immense, but silence remains complete. Geological processes unfolded over millions of years to form that canyon. Stretching, breaking, settling. If something in your life feels wide and deep, a space created by change, that too can be a landscape rather than a wound. Mars continues its slow rotation. Sunlight enters the canyon each morning and withdraws each evening. The chasm does not close. It simply exists, part of the planet's structure. There are polar vortices on Venus. Despite its slow rotation, a Venusian day lasting longer than its year, the planet's upper atmosphere circulates rapidly. At the poles, spacecraft have observed swirling vortex patterns in the cloud tops, sometimes forming double-eyed structures that resemble giant atmospheric spirals. These vortices are driven by thermal contrasts and atmospheric dynamics within the thick carbon dioxide envelope that surrounds the planet. From space, Venus appears smooth and bright, its clouds reflecting sunlight uniformly. But at its poles, motion gathers into rotating forms. You might imagine looking down on that swell from orbit, a subtle spiral in a sea of pale yellow cloud. Even slow rotating worlds can host active patterns. The solid surface of Venus turns gradually beneath its atmosphere. Above it, winds race around the planet in just a few days. Layers move at different speeds. If part of your experience feels calm and grounded, while another part moves more quickly, that layering is natural. Venus continues circling the sun. Clouds wrap around it in continuous motion, and the polar vortex turns, unseen by human eyes except through instruments. There are echoes of ancient impacts still traveling through space. When asteroids collide, they can create families of fragments that share similar orbital characteristics. Over time, these fragments spread slightly, but their shared origin can still be traced. In the asteroid belt, scientists identify these families by examining orbital elements: semi-major axis, inclination, eccentricity. Patterns reveal history. You might imagine a collision long ago. Two rocky bodies meeting in silent space, shattering into many pieces. Those pieces disperse gently, each following its own path, but retaining a relationship in motion. Even separation does not erase origin. If something in your life branched into many directions, projects, ideas, connections, that branching can still share a common center. Asteroid families orbit the sun for millions of years, their trajectories slightly varied but linked. Jupiter's gravity influences their edges. Solar radiation nudges their smallest members. And yet, the pattern persists. There is a faint blue glow around Earth, called air glow. Even on nights without auroras, the upper atmosphere emits a subtle luminescence. Atoms excited by solar radiation during the day release energy slowly after sunset, producing a dim glow in green, red, and other wavelengths. Air glow is not bright enough to see easily with the naked eye, but sensitive cameras detect it clearly from orbit. You might imagine Earth at night from space. City lights twinkling, lightning flashing in storms, and above it all, a delicate veil of atmospheric glow encircling the planet. Light absorbed, light released. Processes continuing quietly after direct sunlight has passed. If your own mind continues to hum softly after the day has ended, small residual impressions glowing faintly, that too resembles air glow. Earth rotates steadily. Its magnetic field curves outward. Its atmosphere breathes in sunlight and exhales faint light in return. The planet does not fall silent completely at night. None of the solar system does. Sunrise creeps across lunar plains. Canyons stretch across Martian terrain. Venusian vortices turn beneath reflective clouds. Asteroid fragments share ancient orbits. Earth's atmosphere glows gently in darkness. All of this unfolds without asking to be witnessed. You can let the images come and go. You can let one detail fade before the next arrives. The planets are not keeping score. They are turning in wide arcs, in balanced ratios, under steady starlight. And you are allowed to rest within that vast, quiet choreography. Awake, drifting, or asleep, while the solar system continues exactly as it has for billions of years. There are dunes on Mars that slowly migrate. They are made of fine basaltic sand, dark against the reddish soil. Wind, though thin in that tenuous atmosphere, still moves grains across the surface over time. From orbit, the dunes form patterns, crescents, ripples, long linear ridges that trace the direction of prevailing winds. Because Mars has lower gravity than Earth, and because its atmosphere is less dense, the physics of sand movement is slightly different. Grains hop and slide in slow, deliberate ways. Changes that might happen in days on Earth unfold over months or years there. You might imagine standing near one of those dunes, the air cool, the sky faintly orange, the sand shifting grain by grain as wind passes over it. Dunes appear solid and still from a distance, but they are temporary arrangements of particles in motion. If something in your life feels stable but subtly shifting, not collapsing, just rearranging, that too resembles a dune. Mars rotates almost as Earth does. The sun rises and sets. Winds lift and settle dust. And across broad plains, patterns migrate without urgency. There are small moons around Mars that are slowly changing their orbits. Phobos, the larger of the two Martian moons, is gradually spiraling inward toward the planet. Tidal interactions between Mars and Phobos cause the moon to lose orbital energy. In about 30 to 50 million years, it may either break apart into a ring or collide with the surface. Phobos orbits very close to Mars, closer than any major moon to its planet in the solar system. It rises in the west and sets in the east because it moves faster than Mars rotates. You might imagine watching Phobos sweep across the Martian sky in just a few hours, large and irregular, its shape more like a captured asteroid than a smooth sphere. Its fate is not immediate. millions of years remain. Change on that scale is patient. If something in your life feels as though it is gradually drawing closer to transformation, not today, not tomorrow, but someday, that too can be allowed its time. Phobos continues its orbit every 7 hours and 39 minutes. Mars continues turning beneath it. And far in the future, their relationship will shift. There are magnetic stripes on Mars's surface. Unlike Earth, Mars no longer has a global magnetic field. But ancient rocks in its crust preserve magnetized patterns, alternating stripes of magnetic polarity frozen in place billions of years ago. These stripes suggest that Mars once had a magnetic dynamo similar to Earth's, generating a protective magnetosphere. At some point, that dynamo ceased, and the global field faded. The remnants remain in rock, recording a time when the planet's interior behaved differently. You might imagine those stripes invisible to the eye, but mapped by instruments, tracing quiet history beneath the dust. Even when a system changes, traces of its previous state can persist. If part of you remembers how something once was, even after circumstances have shifted, that memory can be like magnetized rock, quietly holding orientation from another era. Mars continues without a global magnetic shield. Its atmosphere thinned over time, partly eroded by solar wind. But the crust still remembers. And orbiting spacecraft read those patterns like a subtle script written in stone. There are planets that wander slightly because of gravitational interactions. Even though we often picture orbits as clean ellipses, the gravitational poles between planets cause small variations over time. These interactions can shift orbital eccentricities and inclinations in slow cycles called Milankovitch cycles on Earth. On Earth, such cycles influence long-term climate patterns, contributing to the timing of ice ages over tens of thousands of years. You might imagine Earth's orbit gently stretching and relaxing over millennia, tilting slightly differently, altering how sunlight distributes across the planet. These changes are not chaotic. They are predictable oscillations within gravitational relationships. If something in your life ebbs and flows over long periods, not randomly, but in quiet cycles, that mirrors planetary behavior. The solar system is not static geometry. It breathes subtly in orbital variations. Earth circles the Sun every year. Jupiter exerts its distant pull. The Moon influences tides, and over tens of thousands of years, the shape of Earth's path shifts slightly, then returns. There are icy rings around Uranus. They are darker and narrower than Saturn's, composed of large particles mixed with darker material. Uranus's rings were discovered in 1977 when astronomers observed starlight briefly blinking out as the rings passed in front of a distant star. The planet itself is tilted dramatically on its side, rotating almost perpendicular to its orbital plane. Its rings follow that tilt, encircling the planet vertically relative to its orbit. You might imagine Uranus rolling along its path around the Sun, rings oriented like a wheel on its side. During part of its 84-year orbit, one pole faces the Sun continuously. Later, the other does. The rings cast thin shadows across its pale blue atmosphere when sunlight strikes them at the right angle. Uranus does not announce its uniqueness loudly. From afar, it appears as a calm blue sphere. Yet its orientation is unusual among the planets. If you ever feel slightly tilted relative to the world around you, not aligned in the most common way, that too has precedent. Uranus continues its slow orbit. Its rings remain narrow and dark. Its axis stays inclined. Nothing compels it to straighten. Dunes migrate across Martian plains. Phobos spirals inward toward a distant future. Magnetic stripes lie hidden beneath red dust. Earth's orbit breathes in long cycles. Uranus rolls quietly on its side. All of these motions are real, measured, unfolding, whether anyone is awake to notice. You do not need to trace each path in detail. You can let the dunes shift without watching them. You can let Phobos circle without calculating its descent. You can let Uranus tilt without adjusting it. The solar system continues its layered movement, some fast, some slow, some visible, some buried. And you are allowed to rest inside that vast, steady choreography, knowing it will carry on gently, whether you are listening closely or already drifting into sleep. There are times when the moon looks larger in the sky, and times when it looks smaller. The moon's orbit around Earth is not a perfect circle. It is slightly elliptical. At its closest point, called perigee, it is about 363,000 kilometers away. At its farthest, called apogee, it is about 405,000 kilometers away. That difference in distance changes its apparent size by about 14%. When a full moon happens near perigee, people sometimes call it a supermoon. When it happens near apogee, the moon appears slightly smaller and dimmer. But even at its closest, the moon does not loom dramatically larger. The change is gentle. You might imagine looking up at a full moon on 2 different nights, months apart. One slightly broader, one slightly smaller. Both steady, both quiet. Distance shapes perception. The moon continues its orbit every 27.3 days. It moves a little closer, then a little farther, then closer again. If something in your life feels more intense at one time and softer at another, that may be a matter of distance rather than substance. The moon does not change its nature between perigee and apogee. Only its position shifts. And Earth continues turning beneath it, tides responding to its gravitational pull regardless of how large it appears in the sky. There are jets on Enceladus that shine in backlit sunlight. When Saturn's moon passes between the sun and a spacecraft, its plumes become visible as glowing fountains, illuminated from behind. Tiny ice particles scatter light, forming delicate arcs that extend hundreds of kilometers into space. These plumes originate from fractures near the South Pole, where tidal heating keeps subsurface water liquid. As pressure builds, vapor escapes into vacuum, carrying grains of ice with it. Some of those particles fall back onto the moon. Some escape into Saturn's E-ring. You might imagine that moment of alignment, the sun behind the moon, jets glowing like fine mist. Light reveals motion that might otherwise remain invisible. If something in your life becomes clearer only when viewed from a certain angle, that too resembles backlit ice. Enceladus circles Saturn every 1.4 days. The plumes pulse in response to gravitational stress. Nothing about it is hurried. Ice lifts gently into space and settles again. There are stable points in Earth's orbit where small objects can gather. Earth has Trojan asteroids too, small bodies that share its orbital path around the Sun, clustered near gravitational balance points ahead of or behind the planet. Only a few have been discovered so far, and they are tiny compared to Jupiter's Trojans. But their existence reminds us that even Earth participates in these quiet gravitational harmonies. You might imagine a small rock drifting along Earth's orbital path, always roughly 60 degrees ahead, maintaining its position because of the balance between solar gravity and Earth's motion. Not leading, not trailing, simply sharing the curve. Stability can exist not only at the center, but at subtle offsets. If you ever feel aligned with something larger, moving in parallel rather than directly alongside, that too has a celestial echo. Earth completes its orbit every 365 days. The Trojans circle with it, held in a quiet, gravitational pocket. The sun shines equally on all of them. There are storms on the sun that release arcs of plasma. Solar prominences are vast loops of glowing gas suspended above the sun's surface by magnetic fields. They can extend hundreds of thousands of kilometers into space. Sometimes these prominences erupt, sending coronal mass ejections outward, clouds of charged particles that travel through the solar system. When such a cloud reaches Earth, it can enhance auroras and occasionally disrupt satellites or power systems. But most of the time, these magnetic structures rise and fall without reaching us. You might imagine looking at the sun through specialized instruments, seeing bright arcs lifting above its limb, curving gracefully before collapsing back down. Magnetic fields shape these forms invisibly, holding plasma aloft against gravity. Even in a star, structure arises from balance. If something in your life rises briefly, bright and energetic, and then settles again, that rhythm belongs to stellar physics too. The sun rotates slowly, about once every 25 days at the equator. Magnetic fields twist and reconnect over time. Prominences glow and fade, and the star continues shining with steady radiance. There are regions of space between planets where almost nothing exists. Interplanetary space is not filled with thick gas or swirling debris. It is mostly vacuum, with only sparse particles and faint magnetic fields passing through. Distances between planets are vast. When spacecraft travel from Earth to Mars, they spend months crossing mostly empty space. You might imagine drifting there. No sound, no air, only distant points of light. That emptiness is not hostile in itself. It is simply spacious. The solar system's architecture depends on that space. Without it, orbits would interfere, collisions would be common. Room allows motion. If your own life feels spacious tonight, perhaps quieter than usual, that emptiness can be supportive rather than lacking. Between Earth and the Moon lies nearly 400,000 kilometers of open space. Between Earth and the Sun, 150 million kilometers. And yet, gravity binds these bodies across that distance. Connection does not require closeness. The Moon waxes and wanes. Enceladus's plumes glow in backlight. Earth shares its orbit with small companions. The Sun lifts arcs of plasma into its corona. Space stretches wide and mostly empty between worlds. You do not need to hold all these scales in mind. You can let the distances expand softly around you. The solar system does not rush. It turns in measured arcs under steady fusion light, and you are allowed to rest, awake, half dreaming, or asleep, while those arcs continue without interruption. There are mornings on Earth when the sun appears slightly distorted at the horizon. That distortion is caused by Earth's atmosphere bending light, a phenomenon called refraction. When the sun is low, its light passes through more layers of air, and the different layers bend the rays unevenly. The result can make the sun look flattened or stretched. From space, this bending creates a thin blue arc around Earth's edge, a narrow line of atmosphere glowing against darkness. You might imagine watching sunrise from orbit. The blackness of space above, the curved limb of Earth below, and a delicate band of blue light separating them. That thin layer contains nearly all the air we breathe. Earth's atmosphere is shallow compared to the planet's size. If Earth were a smooth sphere the size of a classroom globe, the breathable atmosphere would be thinner than a coat of paint. And yet, within that thin layer, clouds form, winds move, birds fly, and people rest. Scale can be surprising. If something in your life feels fragile because it is thin or limited, that does not mean it is insignificant. A narrow band of air can hold oceans of experience. Earth rotates. The sun appears to rise. Light bends through air. And the planet carries its atmosphere with quiet persistence. There are rivers of hydrogen flowing from the sun. The solar wind is a stream of charged particles, mostly protons, which are hydrogen nuclei, continuously emitted from the sun's outer atmosphere. This wind travels outward in all directions, carrying magnetic fields with it. The solar wind does not roar. It does not blow in the way wind does on Earth. It is a tenuous flow, almost empty by terrestrial standards, and yet it shapes planetary environments over millions and billions of years. You might imagine that steady outward stream, invisible and continuous, flowing past planets and moons. Influence does not require density. If something in your life moves gently but persistently, a habit, a thought, a small force, it may shape more than you realize over time. The sun continues its fusion. The solar wind continues its outward journey. Planets respond according to their structures, and space carries the flow quietly onward. There are mountains on the moon that were lifted by impact. When large asteroids struck the lunar surface, the energy released excavated deep basins. In some of these basins, central peaks rose where the crust rebounded after the shock. These peaks stand tall within circular craters, shaped not by tectonic uplift, but by the elastic response of rock to intense compression. You might imagine a basin rim encircling a flat floor, with a solitary mountain rising at the center. Violence in the moment, structure in the aftermath. The moon preserves these features because erosion is minimal. Without wind or water, the shapes remain sharp for eons. If something in your life formed under pressure, not comfortably, but under strain, it may still stand as a structure shaped by that force. Impact does not only remove, it can also raise. The moon continues circling Earth. Its phases wax and wane. Central peaks remain at the heart of ancient craters, lit by sunlight that takes just over a second to travel from Earth to the moon. There are particles in Saturn's rings that are arranged into waves. Though the rings may appear smooth from afar, close examination reveals ripples and spiral density waves caused by gravitational interactions with moons. As a moon orbits, its gravity can tug on ring particles at specific distances, creating compressions and rarefactions that travel outward like waves on water. These patterns are subtle but measurable. They reflect the precise interplay between mass and motion. You might imagine looking closely at a ring segment and seeing slight variations in brightness. Denser areas catching more light, less dense regions appearing dimmer. A moon does not need to touch the rings to influence them. Its gravity acts across space. If something in your life influences you from a distance, not directly present but still shaping patterns, that resembles ring waves. Saturn rotates. Its moons circle. The rings respond in structured ripples. All of it unfolds without noise. There are moments when Earth passes through the debris trail of a comet. When our planet's orbit intersects with the path left behind by a comet, small particles enter our atmosphere and burn up, creating meteor showers. The Perseids, the Leonids, the Geminids. These showers recur annually when Earth moves through the same region of space. You might imagine Earth traveling along its path, encountering a faint stream of dust invisible in daylight. As the planet sweeps through it, tiny grains streak into the atmosphere, glowing briefly before dissolving. A meteor is not a star falling. It is a fragment meeting air at high speed. The shower peaks, then fades as Earth moves on. Recurring events can arise from repeated paths. If something in your life returns at certain times, a memory, a feeling, a pattern, that may be because you are crossing a familiar stretch of orbit. Earth completes its revolution around the Sun each year. The comet's debris remains spread along its own elongated path. When the two align, light streaks across night skies. Then quiet returns. Atmosphere bends sunlight at dawn. Hydrogen streams outward from the Sun. Mountains rise in lunar craters. Ripples move through Saturn's rings. Meteors flare briefly in Earth's sky. All of it belongs to the same wide system of motion and balance. You do not need to keep each detail clear. You can let the river of facts flow past you. The planets continue their steady arcs. The sun continues shining. And whether you are listening closely or already slipping into sleep, the solar system holds its patient course, unchanged by your level of attention. You are free to rest while it turns. There are slow avalanches on Mars. High along the steep walls of craters and canyons, dark streaks sometimes appear and lengthen over time. Some of these are caused by dust sliding down slopes, triggered by temperature changes or small disturbances. In other cases, carbon dioxide frost accumulates during the winter and then sublimates in spring, destabilizing surface material and allowing it to flow down slope in thin sheets. These movements are not sudden landslides crashing with sound. They are gradual rearrangements of fine particles under weak gravity and thin air. From orbit, cameras have captured sequences of images months apart, showing new streaks where once there was uniform terrain. You might imagine standing far from such a slope, watching dust descend so slowly that you almost cannot tell it is moving. Motion does not always announce itself. If something in your life is shifting quietly, a belief, a habit, that change may not feel dramatic. It may look like a faint line where once there was none. Mars continues turning. Seasons advance. Frost forms and disappears. And on canyon walls, material finds new positions under patient gravity. There are moons that are likely captured asteroids. Phobos and Deimos, the two moons of Mars, are irregularly shaped and small. Their surfaces are pitted and uneven, resembling asteroids more than spherical moons. Many scientists believe they may have formed from debris captured by Mars's gravity long ago, or from a ring of material that coalesced into these two bodies. They do not shine brightly in the Martian sky. They move swiftly, especially Phobos, which races across the horizon in a matter of hours. You might imagine looking up from the Martian surface and seeing a lumpy, potato-shaped moon sliding across the sky faster than expected. Not all moons are round. Not all companions form in the same way. If something in your life feels less polished, less symmetrical than others, that does not disqualify it from belonging. Phobos and Deimos keep their paths faithfully, regardless of shape. Mars holds them close, and they circle in quiet rhythm. There are layers in Saturn's atmosphere that separate into bands. These bands are formed by jet streams, powerful east-west winds that divide the atmosphere into alternating zones of rising and sinking gas. Lighter zones appear brighter. Darker belts appear deeper in color. The pattern is not random. It is shaped by rotation and internal heat. Jupiter has similar bands, though more vivid. On Saturn, the contrast is subtler. You might imagine looking at Saturn through a telescope, noticing faint stripes wrapping around the planet like soft brushstrokes. Each band represents a region where gases move in coordinated flow. Atmospheres can organize themselves into structure, even without solid surfaces beneath. If your thoughts sometimes arrange into patterns, not rigid but directional, that too is a form of flow organizing itself. Saturn rotates once every 10.7 hours. The bands circle the planet endlessly, and beneath them, pressure increases gradually without a sharp boundary. There is a region beyond Neptune where objects have orbits tilted at unusual angles. Some trans-Neptunian objects have highly inclined orbits, moving far above and below the plane in which most planets travel. Their paths suggest past gravitational disturbances, perhaps from passing stars, perhaps from unseen distant bodies. These objects do not follow the same flat disk as the planets. They trace long, tilted arcs. You might imagine one of these distant bodies rising far above the solar system's main plane, then dipping back through it, then rising again over thousands of years. Belonging does not require alignment. If your own path feels angled relative to others, not in the same plane, that does not remove you from the system. Gravity still binds these objects to the sun. The solar system is not a single flat diagram. It has depth, and in that depth, variation is held. There are nights on Earth when the moon appears orange near the horizon. This coloration is caused by Earth's atmosphere scattering shorter blue wavelengths of light more effectively than longer red wavelengths. When the moon is low, its reflected sunlight passes through more air, and redder tones dominate. The moon itself has not changed color. Only the path of light has shifted. You might imagine watching it rise over distant trees, warm and copper-toned at first, then gradually brightening to white as it climbs higher. Perception depends on angle and medium. If something in your life looks different at one moment than at another, that may reflect context rather than transformation. The moon continues its orbit, unchanged. Earth's atmosphere filters light in subtle ways, and the color shifts softly from orange to pale silver. Slow avalanches mark Martian slopes. Irregular moons circle quietly. Gas bands wrap around Saturn. Distant objects tilt far above the planetary plane. The moon glows amber at the horizon. None of these phenomena require your effort. They unfold whether you are watching or resting. The solar system is full of quiet adjustments, particles sliding, light bending, orbits tilting. You can let your thoughts do the same. You can allow them to settle into new positions without urgency. The planets will keep turning. The sun will keep shining, and you are free to drift, knowing that everything out there continues its gentle motion, steady and untroubled, whether you remain awake to hear about it or already rest in sleep. There are glaciers of nitrogen on Pluto that move more slowly than almost anything we know on Earth. Sputnik Planitia, the vast, heart-shaped plain on Pluto's surface, is made largely of frozen nitrogen. Though the temperature there is around minus 220 degrees Celsius, nitrogen ice at that temperature is still capable of flowing. Not like water, not even like thick mud. but like something in between solid and very slow liquid. Over long periods of time, convection cells form within the ice. Warmer material rises gently from below, cooler material sinks. The surface is divided into subtle polygons, each one perhaps tens of kilometers across. You might imagine standing on that plane, though the cold would be unimaginable, and seeing an expanse that looks still, almost frozen in time. Yet knowing that beneath your feet, nitrogen shifts gradually. Motion does not need to be fast to be real. If something in your life is changing so slowly that you cannot see it day by day, that does not mean it is not moving. Pluto continues its 248-year orbit around the Sun. Its thin atmosphere expands slightly when closer to warmth and collapses into frost when farther away. Ice flows in patient cycles under faint sunlight, and the dwarf planet carries its frozen heart steadily through darkness. There are dust storms on Mars that can grow to cover the entire planet. Sometimes a small regional storm begins when sunlight heats the surface unevenly. Dust rises into the atmosphere, absorbing more sunlight and warming the air further. That added warmth can intensify winds, lifting more dust in a feedback loop. In some years, this process grows into a global dust storm, wrapping the entire planet in a hazy veil that can last for weeks or months. From orbit, Mars becomes muted, its surface features softened by suspended particles. But eventually, the dust settles. You might imagine watching the planet from space as a storm spreads outward in pale orange swirls, then slowly dissipates. Even large disturbances can be temporary. If something in your life feels all-encompassing for a time, filling your mental sky, it may also settle when conditions change. Mars continues its rotation beneath the dust. The Sun still rises and sets beyond the haze, and when the air clears, the same mountains and plains reappear. There are regions on the Sun that are cooler than their surroundings. Sunspots appear dark because they are cooler than the surrounding photosphere, though cooler still means thousands of degrees Celsius. These regions are associated with strong magnetic fields that inhibit convection, reducing the flow of heat from below. Sunspots follow an approximately 11-year cycle. At solar maximum, many spots appear. At solar minimum, few. You might imagine looking at the Sun through a safe instrument and seeing dark speckles scattered across its bright surface. Even in a star powered by immense fusion reactions, there are cooler patches. Brightness does not need to be uniform. If your own energy varies, bright at times, dimmer at others, that pattern is not unusual in cosmic terms. The Sun rotates. Magnetic fields twist and untwist. Sunspots appear, drift across the solar disk, and fade. Yet the Sun's overall light remains steady enough to sustain planets. There are tidal forces that shape the oceans of Earth. The Moon's gravity pulls on Earth's water, creating bulges on the side facing the Moon and on the opposite side. As Earth rotates, coastlines move through these bulges, creating the rhythm of tides. The Sun also contributes, strengthening tides during full and new moons when all three bodies align. You might imagine standing on a quiet shoreline at night, the water gradually rising, then gradually falling hours later. Tides are not abrupt. They are long inhalations and exhalations of the sea. If your own emotional state rises and falls gently over hours or days, that too resembles tidal motion. Earth rotates once every 24 hours. The Moon orbits every 27.3 days. Water responds to gravity in slow arcs, and the ocean keeps breathing under starlight. There are rings of dust around the sun that glow faintly in infrared light. Beyond the visible zodiacal light, astronomers detect a broader cloud of interplanetary dust warmed by sunlight. This dust emits infrared radiation, forming a subtle glow that can be measured by space telescopes. The particles are remnants, fragments of comets, chips from asteroids, circulating in shared orbits. You might imagine the inner solar system not as empty, but as gently filled with fine material, illuminated and warmed by the sun. Each grain small, each path precise. Structure does not require solidity. A cloud of particles can form a stable system. If your thoughts feel dispersed tonight, not forming one solid narrative, but drifting as many small impressions, that too can be a gentle cloud rather than a problem to solve. The sun shines. Dust absorbs and re-emits light. Planets pass through this faint veil in their yearly revolutions. Nitrogen glaciers creep on Pluto. Dust storms rise and settle on Mars. Sunspots appear and fade. Tides swell and recede on Earth. Infrared glow fills the inner solar system. Everything moves at its own pace. Some motions are visible in a single evening. Others require centuries or millennia to notice. You do not need to match any of those timescales. You can let your awareness slow without needing to measure it. The solar system has room for storms and stillness, for bright flares and dim patches, for rising tides and frozen plains. And you, resting here on Earth, are carried along with all of it, gently, continuously. Whether you follow each detail or allow them to dissolve into quiet sleep. There are moments when Earth's shadow rises into the sky. Just after sunset, if you look in the opposite direction of the sun, you may see a dark blue band along the eastern horizon. That is Earth's own shadow being cast onto the atmosphere. Above it, a pinkish glow called the belt of Venus appears, sunlight scattered through the upper air. The planet is always casting a shadow into space. During a lunar eclipse, the moon passes through that shadow, darkening gradually and sometimes glowing red as sunlight bends through Earth's atmosphere and reaches it indirectly. You might imagine standing outside at dusk, watching the horizon deepen in color, knowing that the shadow you see is not of a mountain or cloud, but of the entire planet you stand upon. Shadows in space are precise. They are cones and cylinders of darkness shaped by geometry. If something in your life feels like a shadow, soft-edged, not permanent, it may simply be the natural result of light meeting form. Earth continues its rotation. The sun appears to sink. The planet's shadow climbs upward behind you. And then night settles fully, without abruptness. There are resonant gaps in Saturn's rings. Within the broad sweep of the rings, there are dark gaps where fewer particles orbit. Some of these gaps are created by small moons embedded in the rings. Others are formed by orbital resonances, places where ring particles would orbit at a simple fraction of a moon's period, leading to repeated gravitational nudges that clear the region over time. The Cassini division is one of the most prominent of these gaps. It appears as a dark band separating the brighter A and B rings. You might imagine looking closely at a section of rings and seeing not only brightness, but absence. A place where particles are sparse because gravitational rhythm has gently swept them away. Structure includes both presence and space. If there are areas in your life that feel empty compared to others, those spaces may be shaped by rhythm rather than loss. Saturn rotates, its moons circle. Resonances maintain the architecture of the rings, and light reflects off ice in luminous arcs. There are faint wisps of atmosphere on Mercury. For a long time, Mercury was thought to have no atmosphere at all, but it does possess a very thin exosphere, a sparse layer of atoms knocked off the surface by solar wind and micrometeorite impacts. Sodium, potassium, oxygen, and other elements drift above the planet, too thin to scatter light like Earth's air, yet measurable by instruments. This exosphere is constantly replenished and lost. Particles escape into space even as new ones are released from the surface. You might imagine Mercury not as entirely bare, but as surrounded by a delicate halo of drifting atoms. Even the smallest planets can carry subtle envelopes. If something in your life feels thin, not substantial like a thick atmosphere, but present nonetheless, that does not mean it is absent. Mercury circles the Sun swiftly every 88 Earth days. Its surface heats and cools dramatically, and above it, a faint veil of atoms lingers, renewed in quiet cycles. There are pressure waves traveling through the gas giants. When storms form on Jupiter or Saturn, they can generate waves that ripple outward across cloud layers. Some of these waves appear as repeating patterns, like ripples on water after a stone has been dropped. These atmospheric waves can persist long after the initial disturbance has faded, traveling across belts and zones. You might imagine a bright storm erupting briefly, then fading, while the waves it created continue outward in widening arc. Cause and effect do not always end at the same moment. If something in your life has already passed, but its effects continue gently outward, that too resembles atmospheric waves. Jupiter spins rapidly. Saturn's bands encircle it in soft stripes. Storms rise and dissolve, but patterns travel on, and eventually, even those waves fade into broader circulation. There are comets that may never return. Some comets follow hyperbolic trajectories, paths that bring them once through the inner solar system before sending them back out into interstellar space, never to return. Others are perturbed by planetary encounters, altering their orbits permanently. When a comet approaches the Sun, it brightens, shedding gas and dust in a glowing coma and tail. Then it recedes, dimming. You might imagine one such comet appearing in Earth's sky once in recorded history, then departing on a path that will not cross our orbit again. Not every orbit is closed. Some journeys are singular. If something in your life comes once and then moves on, not returning, that too is part of cosmic possibility. The solar system is not entirely circular in its patterns. There are one-time visitors and long-term companions. Earth continues its yearly path. Jupiter maintains its 12-year rhythm. A comet arcs inward, brightens, then drifts back into darkness. Earth's shadow rises at dusk. Gaps open in Saturn's rings. Mercury carries a whisper of atmosphere. Waves ripple through giant planets' clouds. Comets trace paths that may not repeat. All of this unfolds in wide, quiet geometry. You do not need to predict which events recur and which do not. You can let the facts pass through you like starlight through air. The planets will keep turning. The sun will keep radiating. And whether you are awake to hear these final details or already slipping into sleep, the solar system continues its patient motion, steady, spacious, and entirely untroubled by how much of it you remember. There are places on Earth where you can see the International Space Station glide across the sky. It does not flash like an airplane. It does not blink. It moves steadily, a bright point crossing from one horizon to another in a matter of minutes. It orbits Earth about every 90 minutes, traveling at roughly 28,000 kilometers per hour. And yet, from the ground, it appears calm. The station remains in orbit because of a balance between its forward motion and Earth's gravity. It is always falling toward Earth, but moving forward quickly enough that the planet curves away beneath it. You might imagine looking up at twilight and seeing that small, moving light, knowing that inside it, astronauts float gently in microgravity. Orbit is not suspension. It is continuous falling in a curved path. If something in your life feels like motion without contact, like you are suspended but still moving, that too can be a kind of orbit. Earth turns. The station circles. Sunlight reflects off solar panels in brief, steady brightness, and then it slips into Earth's shadow and fades from view. There are tiny moons within Saturn's rings that carve narrow gaps. These are called shepherd moons. As they orbit, their gravity pulls on nearby ring particles, confining them into sharp edges and clear divisions. Pan and Daphnis are two such moons. They move within ring gaps, keeping those spaces defined. You might imagine a small moon traveling through a thin channel in the rings, ring particles flowing around it, like water around a stone. The moon does not need to be large to shape its surroundings. If something in your life feels small but influential, a habit, a word, a presence, that too can define space. Saturn's rings are not rigid disks. They are fields of motion guided by gravity. Shepherd moons pass quietly through them, maintaining structure without noise. There are ancient lava plains on Mercury that are smoother than their surroundings. After early impacts formed large basins, molten rock welled up from below and flooded those depressions, cooling into wide plains. These smooth regions contrast with heavily cratered terrain nearby. You might imagine a landscape shaped first by impact, then by molten flow, then by cooling into quiet stillness. Time layers one process atop another. If your own life contains phases that followed one another, disruption, then renewal, that sequence is not unusual in planetary history. Mercury's surface holds both rough and smooth regions side by side. The planet rotates slowly under intense sunlight, and ancient lava plains rest beneath a black sky. There are faint arcs of light in Earth's upper atmosphere called sprites. Sprites are brief flashes that occur high above thunderstorms, reaching upward into the mesosphere. They are triggered by powerful lightning discharges below. They last only milliseconds and are difficult to see with the naked eye, but cameras have captured their branching, reddish forms. You might imagine a storm far below, lightning striking within clouds, and above it, a fleeting, luminous shape blooming and vanishing almost instantly. Energy can travel upward as well as downward. If something in your life feels like a quick illumination, brief but striking, it does not need to endure long to have occurred. Earth's atmosphere layers upward from troposphere to stratosphere to mesosphere and beyond. Within those layers, processes interact in ways that are often invisible from the ground. And still, the planet continues its steady rotation. There are regions near the sun where dust can only survive briefly. Very close to the sun, temperatures become so high that dust grains sublimate, turning directly from solid to gas. This creates an inner boundary to the dust disk in the solar system. Inside that region, particles cannot persist for long. You might imagine a grain drifting inward, warmed more and more as it approaches the sun, until eventually it dissolves into vapor. Proximity changes survival. If something in your life feels unsustainable under intense conditions, that too mirrors physical reality. Distance can allow persistence. Nearness can transform. The sun shines steadily. Dust spirals inward slowly under radiation pressure and drag. And at a certain point, material becomes something else entirely. The space station circles Earth in quiet arcs. Shepherd moons maintain narrow ring gaps. Lava plains smooth Mercury's basins. Sprites flicker above thunderstorms. Dust dissolves near the sun. All of these are parts of a single, layered system. Some processes last milliseconds. Others span billions of years. Some are visible to the naked eye. Others require instruments and patient measurement. You do not need to sort them by importance. You can let them coexist in your awareness, or let them drift apart. The solar system continues its balanced motion without asking for attention. Planets turn, moons circle. Light travels outward from the sun in all directions, and you, resting here on Earth, are carried along with all of it, gently, steadily, free to remain awake or to slip into sleep, while the quiet mechanics of the cosmos unfold exactly as they always have. We've wandered a long way tonight, across nitrogen plains on Pluto and slow avalanches on Mars, past shepherd moons and faint rings, through dust drifting in sunlight and shadows rising at dusk. We've watched storms bloom and fade, ice rest in craters, comets arc inward and slip back into darkness. And through all of it, one quiet truth has remained. The solar system does not hurry. Planets turn at their own pace. Moons circle faithfully. Light travels outward without urgency. Even change, even collision, even eruption eventually settles into orbit again. If you are still awake, you might notice your breathing now. Not because you need to change it, just because it is there, steady, automatic, like rotation, like tide. If you have drifted in and out, missing pieces, that is perfectly all right. Nothing out there required you to witness it. Jupiter's storms did not intensify for your attention. Saturn's rings did not brighten for your memory. Pluto's ice continued its slow convection, whether or not you followed the explanation. You were never responsible for holding the solar system together. It holds itself. And you, on this small, rotating planet, wrapped in a thin blue arc of atmosphere, are allowed to rest inside that stability. If sleep is near, you can let it come without ceremony. The sun will rise on Earth whether you hear this final sentence or not. The moon will continue its orbit. The distant planets will keep their patient paths in the dark. If you are not sleepy, that is welcome too. You can remain here quietly, feeling the simple comfort of being one small part of something vast and balanced. The solar system is wide. It is steady. It is in motion, but never in a rush. And tonight, you do not need to move at all. Thank you for spending this quiet stretch of space and time here. Rest if you'd like. Stay awake if you prefer. Either way, the planets will keep turning gently above you.